Thank you all. Can you hear me?
Can you hear me? Okay. First of all, thank you all. You are extraordinary. Really fantastic. I must say, I connect a bit to what Nicole was saying before, because in the last 30 years, I really don't remember conferences on this topic or similar with such a large participation request. It was really a surprise, even for us, a very pleasant surprise, of course, because you truly give us the right energy to continue in this work, which is really exhausting. And so thank you. Give yourselves a round of applause, because you are truly extraordinary. Thank you. I say this without emphasis, honestly, but I believe you truly are the vanguard of a new Zepptepi, of a new time. Because from today, a new page of history begins to be written. Perhaps history, and I don't want to exaggerate, the true history of our distant past. Because thanks to what I have always defined as a new enlightenment, at the moment when it unites experimental archaeological research with advanced technology, creates a partnership that, in my opinion, is truly very effective, because based on scientific data, we can truly reconstruct, I would say, definitively, what happened in our distant past. This project, Project Khafre, we call it that at this stage. Then I'll explain why. It was born on a specific date. It is the 1st of September 2022, when a dear friend, Pino Morelli, whom I mention with great affection, wanted Professor Corrado Malanga and me to meet in Pescari. It was a wonderful 2-day event, also because when you are with Professor Malanga, with Corrado, there is always something to learn. So it was truly an extraordinary 2 days where we discussed some topics. They, Corrado and Filippo, were coming from the experience of studying the Pyramid of Cheops, which in my opinion was truly groundbreaking. And it is groundbreaking. While I, on the other hand, came from a research path that began in 2021 on the north shaft of the Queen's Chamber, which I was sharing at that time with Manu Safstrade, who is a Californian researcher, and with Jean-Paul Boval, the brother of the more famous Robert, the author of the correlation theory. That experience was important because I am, so to speak, a bit like St. Thomas, in the sense that when I saw there's an extremely serious research project, I delve a bit into the details to see if there is any correlation with the research path I was following. And coincidentally, they were working on the Pyramid of Cheops, while I was studying a detail of that
pyramid.
This image refers to a section of the north shaft of the Queen's Chamber. We are precisely at the 4th block from the start of the shaft slope, the 7th from the entrance, where we had noticed a somewhat series of fragments on the floor of the conduit, which led us to imagine that the fragment shot onto the opposite wall, because they had tried from the outside to force it.
In particular, it reminded me
another passage that is little known, which is inside the chamber of the Great Pyramid, exactly in the entrance passage toward the antechamber of the King's Chamber, known as Cavia Passage, who dug, because he had found this hole, had sneaked in. And during the course of the digging, he found himself exactly at the height of the north shaft of the king's chamber. You can see the development of the shaft from that crevice. In this case, in the Queen's chamber, they had tried to force it, but what is very interesting instead is the upper part towards the 9th block of the conduit, where a gap, a tear, is indicated by these arrows on the right side of the wall. There too we find debris, so which are seen better here, making the tampering at that point evident. Moreover, among the debris we found an entrance ticket to the archaeological area of Giza that was in sale in the period between 1973 and 1991, and a small reel which we eventually discovered is film from a movie camera, as they used to call it then, of craftsmanship Russians. So evidently someone had entered that environment and left a mark of their passage. I believe, moreover, that these elements were not left there by chance. And so I wanted to delve into this detail to then understand at what height this area was located, and if this environment matched the reconstruction that Corrado and Filippo had made. Honestly, I don't know why, but this is one of the two areas you marked in green. It's not a coincidence, of course, because coincidence doesn't exist, but that room matches exactly with this area drawn in green in the reconstruction made by Corrado, Biondi, and Filippo. So it was the mathematical certainty, I would say, that the project they were working on and the technology they were using was perfect, precise, and that thanks to this technology, further steps forward could be taken in the research. So that's how fundamentally the Khafre Project was born, which is primarily a project about people, because we truly created an extraordinary cohesive group, almost to the point of telepathy. Truly a magnificent relationship was formed, and then I enrich myself day by day because I deal with geniuses, and therefore for me it is truly an extraordinary experience. As you all know, for those who follow me, that in 2010, during a conference held at Zayed University in Dubai, I presented my theory on dating the Zepptepi, which is a project that goes a bit beyond the correlation theory of Robert Boval, from which I started. And why Robert had focused attention only on the pyramids and the Sphinx, dating the site to 10,500 BC, I wanted to take a further step. Having identified certain limits, both in the technical analysis of the alignments and in identifying all those possible elements present on the Giza Plateau that could provide an additional contribution to the research, and thus expanding the scope of analysis and proposing, let's say, a more coherent dating with what was present on the Giza Plateau. And so we arrived at 36,400 BC, where this set of elements of monuments, so I am not referring only to the three major pyramids and the Sphinx, but also to the mastaba of where the mastaba of Khentkawes is currently located, the tomb NC2, to the temple of Amenhotep II, and two temples at the foot of the Sphinx. In short, a whole series of elements that allowed me to define the Giza Plateau from east to west, aligning all these elements entirely with the celestial vault. There was a precise alignment. So I believe that date
can surely be the starting point for historically defining the Zepptepi. This study then led me to ask a second question. If this complex is so ancient, who could have built, realized it? Who made this blessed, extraordinary work?
And so here a path had to be chosen.
And the way, in my opinion, most useful to also understand the consistency of the entire setup was to get into the mind of the serial killer, that is, who really created that structure, to understand how he thought, in what way he developed it from an architectural, engineering, and not only that, also scientific point of view, using, let's say, more complex and broader terminology, to understand what the communication systems of this civilization were. We can obviously refer to a form of phonetic communication, but the problem is that in the pyramids of Giza, there isn't a shred of a hieroglyphic, and I don't consider Weiss's scribble that is in one of the chambers, the so-called dumps of the Zepp. By now, it is known to everyone that it's a fake. So what could have been the other communication system? The language of numbers, the universal tool, the tool of universal language, because through numbers, codes are communicated that transcend space and time. Another important aspect was the study of astronomy, because through this tool it was not only possible to date the site, but it also gave us additional elements for evaluation in light of what was emerging from an ongoing research, connections not just with the surface but also with the other world. Let's define it that way. The underworld, as the English say, which step by step was coming to the light, just like geometry, but also the analysis of the archetypes that emerged from the very creation of some monuments built on the Giza Plateau, as we will see shortly. For example, in the Valley Temple, which is one of the two temples, the one on the right, located beneath the Sphinx. So, entering the mind of those who created that structure was fundamental. And this was thanks to the study of various authors, such as, for example, George Hart, who is an archaeologist who worked at the British Museum. Let's say a series of publications on the various deities of the Egyptian pantheon, and in particular on Thoth, the deity called Thoth, which seemed to be not only very interesting for the aspects it analyzed, but seemed to be the deity most closely related to the construction of the entire structure of Giza. And so I started from there to delve deeper into this topic and understand how much Thoth could be connected to the entire framework of Giza. And gradually a whole series of elements emerged that we will see shortly, but above all, it became necessary, so to speak, during the course of our research, to delve deeper into certain details on site that could be useful for the research. And so, within the context of the Egypt Unveiled tour, so to speak, we combined business with pleasure, in short, right? So we went to Egypt to evaluate, to visit the Giza Plateau, and in particular the pyramids and monuments that have been most important, essentially, that were built in that area, but also to take a peek at some elements concerning both the Pyramid of Khufu and the Pyramid of Khafre. I won't talk about the Pyramid of Menkaure, perhaps we'll do that another time, but I can hint that there are some very, very interesting things there too. Regarding the Pyramid of Cheops, the first thing I want to analyze with you are these blocks located on the north facade of the pyramid, and in the section leading to the entrance of Al Mamun. So what was, let's say, forcibly created from the inside. Therefore, anyone who tells you that this entrance was made from the outside is essentially stating an inaccuracy for a whole series of reasons. The first is that he must have had outrageous luck to find that entrance right at that point. In reality, it comes from underneath, and later we will see from where. And so these blocks show deep traces. They are in sandstone, deep traces of water erosion, and only on some blocks of the north facade and on some blocks in the northwest corner of the Great Pyramid. And these 32 points I analyzed. And this means that already in around, let's say, 10,500, then the period to which he attributed the alignment, probably during that period something happened that demolished part of the covering that characterized the Great Pyramid, exposing these blocks to water erosion, because then that area was submerged over time by seawater. In short, therefore these traces of water erosion were very, very important. This, however, is the plateau in front of the east face of the Great Pyramid. It is limestone paved area, and I can assure you that this plateau, it is made up of blocks so large that they did not even fit into the camera. They were so extensive, perfectly worked, perfectly cut, and aligned with each other, surrounding the entire structure. And later you will understand why this detail is important when Professor Corrado Malanga speaks. And this characterization of the base of the Pyramid of Cheops is also found in the Pyramid of Chephren and the Pyramid of Mykerinos, and as well in the area of the Sphinx. Another interesting aspect, it was Filippo who asked me for information about the Grand Galleria. What you see here is a detail of the entrance right in the Great Gallery, meaning practically when you exit the ascending shaft looking up, there is this granite block that obstructs. A hole is practically a plug that probably leads somewhere else that at this moment we do not know or have not yet seen physically. And it is located exactly at this point you see in the white circle, which corresponds precisely to what Corrado and Filippo identified in their reconstruction of the interiors of the Great Pyramid that you see here in the red circle. Then there is another very interesting element, and Filippo had asked me to pay particular attention to this because it is a hole that has been sealed with this block of granite, and this point is exactly at the highest part of the wall, east of the Grand Gallery, right at the top. And there is another obstruction that definitely leads to some other chamber they reconstructed in their work on the pyramid, on the Great Pyramid. And then we come to the King's Chamber. Cool. At this point, there's that famous opening towards the chamber below the one that is right beneath the King's Chamber. On that occasion, I spent time with the two custodians who are inside the chamber, basically, who manage the flow of access to that area. We engaged in a brief chat actually, but I asked some very specific questions about the environment below. After a moment of, let's say, their embarrassment, and they were also a bit reluctant, so to speak, to talk about it, gradually interesting things came out. So, probably all of you have already seen this image. It is a wall that is obviously not from the Egyptian period. Here, this wall was built during the 1980s in response to my precise question about what the need was to create this obstruction. They revealed to me that beyond this wall there is a corridor that goes down for several meters. Then it splits into another passage that goes upward. This detail about it going upward is important.
And then this conduit leads further down to a well.
So there is a well at the end of this path. It is very likely that whoever explored that chamber we saw earlier in the tunnel, when I talked to you about the northern tunnel of the Queen's Chamber, passed right through that opening and took the direction upwards and entered that environment. So it is from there that they passed. And let's move on to the Pyramid of Khafre. The visit to the Pyramid of Khafre was very interesting because, in truth, it was the first time I accessed that monument. It has a different layout compared to the interiors, at least the ones we know. Then we will show you the others later. It has a different layout compared to the Great Pyramid. It is interesting to note that at the end of the descending passage, from the entrance to the end of this passage, once the passage is finished, you enter a horizontal passage that is also quite tall. In fact, I could stand upright, unlike the descending passage, which was a bit difficult for me to go down because it is low, around 1 meter in height. There is this niche. What you see here inside the niche is a contraption from Scan Pyramid that is detecting the famous muon particles in the hope of catching one and reconstructing a bit of the internal environment according to their technology, which, for goodness sake, we respect, but I mean, at least I believe it is, let's say, not very effective in uncovering the secrets that monument holds. This niche is actually here, in the reconstruction you see in here, in the graphic reconstruction, the position of the niche relative to the duct going down isn't exactly precise because it is located right in front of the door, which leads to the second known chamber of the Pyramid of Khafre. We would have liked to explore that area, but how should I say? We were denied access. I won't hide from you that we also tried to push our way in, but it wasn't possible. So it means that down there, not only are there the machines of the Scan Pyramid, but I hope they haven't done the same damage they did a few years ago in the Queen's Chamber of the Great Pyramid, where they even drilled the floor to check if there was an environment beneath the Queen's Chamber, like in the case of the King's Chamber. So, in any case, we were not able to explore it. This instead is a detail of the horizontal shaft that leads to the chamber of Belzoni, which can be accessed by going up a short ascending passage that leads further up towards this other horizontal corridor that leads into the Belzoni chamber. Here too we are on the left wall, proceeding towards the so-called funerary chamber. And I have identified this detail, the block, which I will highlight better for you here. And this too seems to be a plug that obstructs an opening because it is completely shaped in a way entirely different from the others, which are much more linear. So it is possible that behind this plug there might be something interesting. And this instead is another niche located a few meters above. This niche is very interesting because the inner block is pink granite, while the one that blocks it is a block of sandstone. It blocks it because it blocks it in the sense that it's not possible to extract it without removing the piece above. So it's possible that this particular feature of the block of granite compared to this sandstone that characterizes the conduit, it may hold some surprises. Finally, with Ghiartaro in Belzoni's chamber. We entered Belzoni's chamber, which is something nice, exactly 207 years after its discovery, because it was March 2nd, 1818 when Belzoni entered it, whereas we entered on March 2nd, 2025, so it was very nice. And there is something very interesting in this chamber because these two images give you an idea of the existence of two shafts. These are the opposite walls and are exactly corresponding, but there is another element that seems very interesting, which is this hole that has been made in the upper corner of Belzoni's chamber on the left of the entrance. It is interesting to note because corresponding to this hole on the opposite wall, maintenance work was done there and is evident. Probably there were two other shafts that characterized this space. Obviously, we will try to verify this if possible, because it seems to me that it is not extremely simple to do this, also because they are very, very small conduits. However, the interesting thing is that in this chamber, compared to the King's Chamber and the Queen's Chamber in the Pyramid of Cheops, it presents a pair of shafts, a double pair of shafts. Another very interesting thing, I noticed it while examining the surviving blocks of the flooring of Belzoni's chamber near the so-called basin. Well, academics call it a sarcophagus. For us, it's a basin. For me, it's a basin. Because these blocks that are around the container have holes well defined. And I must say quite deep. They are about 7 or 8 centimeters, if not a little more. Rightly, Professor Malanga pointed out to me that these were very likely blocks used to insert rods, poles like that, to slide the lid and then eventually pull it back and close it again. And so even these blocks, these details, have a very useful peculiarity that also, let's say, aligns with this idea we have of the function of these monuments. Finally, this is a small detail. It is a limestone block that is located in a niche right at the end of the descending passage. That seems to be the closing door of that, which essentially separates the descending passage from the first horizontal passage.
Finally, the Great Pyramid is rarely talked about, but in reality, this monument has been particularly studied using technology.
First of all, we said that it was, so to speak, explored by Belzoni in 1818, and later by Perrin, Weiss's friend, who is the author of the little drawings in the relieving chamber of the Z.
they explored this monument, but actually one of the first and most interesting experiments was carried out in 1967 by Professor Luis Alvarez, who later in 68 was awarded the Nobel Prize in Physics. And already in 1967,
This famous moon technology was used.
on that occasion, considering the equipment they had at the time, they didn't succeed in 2025. In 1967, they managed to explore only a small volume of the pyramid, about 18%, naturally with negative results. Other experiments have been conducted by both CERN and the University of Riga. And this latest study that was conducted on the pyramid is very interesting, because as part of an engineering symposium, in short, it was fundamentally unrelated to archaeological research. Fractures were identified in the northeast area of the pyramid, along some courses toward the base. According to these researchers, it suggests or hints at the possible internal collapse, therefore in empty spaces. From this, it was deduced that there could be unexplored areas inside the Pyramid of Khafre. Another temple, another very interesting monumental complex, is the one near the Sphinx. In particular, I had the opportunity to analyze some structural elements inside the Temple of the Valley, which is the one located to the right of the Sphinx. Why? Because practically this temple presents a dual structural characterization made of sandstone blocks. This is an image taken from the southeast corner of the temple. You see these enormous sandstone blocks that form the entire perimeter,
And that show, let's say, deep traces of erosion.
and then there is an internal part that is made of granite. In the academic version, this temple would have been maintained during the period during the Old Kingdom, therefore during the reign of Khafre, to whom this temple is attributed. And it is attributed to Khafre not because there is any archaeological evidence proving this link between Khafre and the Valley Temple, but simply because it was found in a well, a diorite statue of Khafre, actually upside down. So let's say, from this discovery, let's say that the equation was born like this: Temple of Khafre, Pharaoh Khafre. In any case, what is interesting is the size and the cut of these granite blocks, which are enormous. I believe that even here, the largest ones weigh around 70-80 tons.
Moreover, with an extremely, let's say, precise conjunction.
In addition to a cut, this piece of granite has been specifically cut to form a curve that matched with the other sides. So truly a technology that during the Old Kingdom period, and particularly during the Fourth Dynasty, is not objectively recognized to the Egyptian civilization, which at that time still used wooden mallets and copper chisels. So working granite, because to work granite, something much more was needed. One thing that has always intrigued me is the shape of the Valley Temple. And here you see a graphical projection of it. Valley Temple that, how to say, has always given me the sensation of something different from the design of a temple. It almost looks like how to say, a plate for how to say, electrical transmission, then if more circuit, let's say, microchip, a circuit. What is interesting, though, as I was telling you before, is to use the syntax of thought, enter the mind of the serial killer, and analyze the simplest elements that come to our eyes. Because, let's say, the only way to convey a message in the future is to use a very simple language. So, what do we see here on the left? We see a kind of fork with 3 prongs.
So we have a number 3.
Then you also see the development of the colonnade. Here too, there are a series of columns that give us a number. Practically, there are 16 columns at the base forming this temple. So practically the sum of 7. And then we have an element here on the right, which is indeed formed by a niche. That's the one you see at this point,
Where there is the number 1.
So the numbers that come out are 3, 7, and 1.
which coincidentally seems to be an anagram of the number 137. And this already seemed like, let's say, an incentive to delve deeper into this game. Now, in the archetypal reading of these elements, it was not difficult to associate this number 3 and that shape of the number 3 with this letter, which we find, so to speak, in the Hebrew alphabet, which is the Shin, which in itself gives you this meaning of the transforming form of a man reincarnating into a new life. So we are beginning to have, so to speak, a small detail about what the Valley Temple could convey as a meaning. Another interesting aspect, however, is the shape of the one that reminds us of the Tao. And here too, in its, shall we say, archetypal meaning, there is something that brings us, so to speak, both to the reincarnated and to the completion of an extraordinary work. And it is equally interesting to note that the development of the temple seems to recall instead another letter, which is Zain, which practically gives us this concept of immortality. So all these elements combined led us during our study, which we were developing with the underground of Giza, to the city of Amenti and its symbolic function in ancient texts, in the Book of the Dead, in the Book of the Hidden Chamber. Amduat, in the pyramid texts, speaks of a city of the dead over which Osiris reigned. City that envisioned, so to speak, a journey during the 12 hours of the night that are referenced in the Amduat, during which the soul of the pharaoh would pass to be reborn into new life and re-enter the Amduat. The interesting thing, however, that I wanted to understand was why this 371 and they did not reverse the symbols to then bring them back to 137. Now, there are many formulas, different mathematical formulas, arithmetic, mathematical basically, that can be applied to this number, which I wasn't really interested in because I was actually focusing on the symbolism. To that symbolism that could use connect mathematics, or at least the elementary symbols of arithmetic with Egyptian symbolism. And the only formula applicable to this number that could be connected to the cross, no, the Ankh, which is in the hands of the gods, symbol of life and symbol of life in the afterlife, was the function of sigma. The sigma function, which is a function, you see it here, applied to all the natural divisors. What does it return for this number? This is really interesting. I believe that chance does not exist. The result of the sigma function applied to 371 gave us 432. No fimbado. So we had found, I found another code
that combined with 137 conjugated space-time with immortality and gave us an indication of what might be beneath the Giza Plateau.
I will move on quickly because we have limited time. A little bit more.
So this
Further element, this further code that emerged from the interpretations of these symbols and allowed me to, do you remember, enter the mind of the serial killer and read the syntax of their thoughts, inevitably pushed me to delve deeper. Another text that is particularly controversial is the famous Emerald Tablets. We all know the story of the Emerald Tablets. In short, the origin is not considered a reliable text by the academic community, perhaps rightly so, because the original of this text has never been found. But this text also tells us things that are very, very interesting. Of this book, during the work we are doing, I only consider the descriptive aspects of the city of Amenti, so leaving aside everything else that interests us little at the moment. Maybe we will analyze it when we have an even clearer idea of what is emerging from this work of research. However, the Emerald Tablet started to have, so to speak, a very interesting role, to the point that I said to myself, you see, we haven't found it. This text, the original isn't there, but maybe we can give it a historical sense only through the reconstruction of what we are finding. And from here, as you might say, a series of explorations emerged that we wanted to conduct on some elements of this book. And so one evening with Filippo, we focused on the 15th tablet of the Emerald Tablets, because there we identified a language.
Unknown. A language that
gave us no coherent answer. And so we analyzed these sentences that made up this text. Moreover, it should be repeated according to the instructions of thought, like a mantra to experience, let's say, in other dimensions. These are the sentences. I'll list them quickly for you. We examined them, and looking at them more closely, they did not provide any, any answer. They truly seemed like phrases, letters placed randomly. However, upon closer analysis, let's say they gave us some resonances that reminded us, on one hand, of some, phrases or resonances with the Mesopotamian language, therefore Sumerian, and others that instead gave us resonances with Proto-Semitic languages. From here, we decided to further study these texts and syllabicate them correctly. And so we identified, let's say, the best formula, which is this one, to read them and to give, so to speak, a complete sense to these phrases. Let's see what the first one means. Dor el il-la means the temple of Thoth as a tool of the spirit. Read the translation carefully and you will understand why we are heading towards Amenti. There, Umgang means the tool of the spirit. Remember the work by Professor Malanga and Filippo on the Great Pyramid? The tool of the spirit makes people free and aware. Cut or detach from the material to serve the divine. Praise the Son of God, or the deity in general, rock on which to write the works of the kingdom. So let us remember Thoth's function in the Emerald Tablets and all that it tells us. The primordial spiritual entity forges the divine spirit.
So we had identified a series of elements that pushed us even more to consider that what was coming out from the underground of Giza could actually be something that could be associated with the city of Amenti. Now, about the etymology of the word Amenti, in reality, as it were, we have in the Egyptian texts reference to a deity, which originates, let's say, in the Middle Kingdom, called Event. Event, the final double T generally indicates a feminine form.
And or Amenti.
So, because in the Egyptian language, vowels do not exist except in the famo at the beginning of the word. So we started trying to understand if the same Amenti could show us something more and be certain that what we were seeing could really be Amenti. Actually, divided in a certain way, the word Amenti means seed or water of the divine power of life.
So the divine power of life, water, as the basic element of this entire framework,
United with 137, which in archetypes means entry into the house of life, it made us think that while Khafre could represent the entry into the divine house of life, Amenti was the place described in ancient texts. There are then a whole series of other elements that you can read here in the slide.
Or characteristic elements.
The city of Amenti. There are two things you will see next. These two enormous areas that were identified during the surveys with the SAR, which are specifically mentioned in the descriptions of the emerald tablets. These two large environments, infinite like space. So we are identifying two large chambers that are, let's say, truly as far as the eye can see. There is another thing described in the emerald tablets related to the construction of Amenti.
at a certain point of the
During the construction phase, deep wells were created to bring light and life from mines. It is described this way in the emerald tablets. The Giza Plateau is characterized by for those who, I don't know how many of you have had the pleasure of visiting that area, but on the Giza Plateau there are many wells that were made in the distant past. They are definitely not of dynastic craftsmanship. That characterize those areas both near the pyramids and in spaces even further away. And I am referring in particular to the area northwest and southeast of the Giza Plain. So actually there was some other element in the description of the halls of Amenti, in the construction of Amenti, that seemed to match with what we were observing during the surveys. Finally, another aspect that seems really very interesting to note is that in the concept of the afterlife of Egyptian civilization, there are references to Amenti, references to the Rostau, and references to the Duat. Now, the Egyptian civilization is characterized by the concept of duality. Yeah, we find duality in the spiritual part, basically and in the conception of time, linear time, circular time, and the jet, as well as in everyday objects that were used.
Exactly.
Even in the simpler aspects of daily life, Here, however, it seems that it goes beyond duality, which is not something too little. Where we have Amenti, which is the afterlife, the one we have been looking at for some time, there is Rostau, which refers to the surface of Giza, where the pyramids, Sphinx, and so on are located, and then the Duat, which is the counterpart in the celestial vault.
So we are in the full application of the principle as above, so below, as above, so below, which we find in the philosophy of this deity called Thoth.
And here,
And then I'll close. What is the relationship between Giza, Zepptepi, and Amenti?
In reality, we can, as I was saying at the beginning, perfectly understand what is the construction and architecture of Giza only if we study it in its entirety. So from east to west, do not focus only on the pyramids or only on the Sphinx or only on the two men C2 and so on, but we can understand its complexity only by analyzing it in its entirety. So from east to west, and at this point also from bottom to top. So while in the east we have the Sphinx as the guardian of life, at the symbolic sunrise, thus life that develops from the sun along the ecliptic. But our daily life, the life of the pharaoh, his daily routine, so the guardian of birth, then we have the entrance to the west, Imentet, Amenti, the goddess of the western hill, a symbolic place of death for the ancient Egyptians, then the path along the city of Amenti, in the underground of Giza, until reaching the Sphinx again, to materialize that concept of birth, death, and rebirth, that is an integral part of the entire spiritual and religious structure of ancient Egypt.
And here I will be silent and pass the word to my colleagues, thanking you all for your attention. Thank you.
It works. It's normal. Yes, yes.
Consider that the first 2 points, I will explain a bit about the state of the art of satellite remote sensing. And then we move on with a technique we invented to try to understand how things work and how we manage to obtain underground scans. And then I will present some case studies. So a brief mention of the Pyramid of Cheops or Khnum Khufu. And then other things such as other experiments we conducted on the Gran Sasso in Italy, or on the Mosul Dam,
Or on the gutter tunnel before handing over to the professor.
So we used employed the so-called synthetic aperture radars, and therefore I will explain to everyone what the word aperture itself means and what synthetic aperture is, because things need to be well understood. Well, it should be noted that synthetic aperture radars are mainly mounted on satellites that are in space. And predominantly, actually solely, not predominantly, they are placed in low orbit only. Low orbit is that orbit which occupy circles in space that have a distance from the Earth's surface ranging from 400 to 700 kilometers, so they are primarily close to us. Just to be clear, there are two other orbits, two fundamental orbits, the intermediate orbit are predominantly placed before and after the Van Allen belts. So around 14,000 kilometers and 18,000 kilometers. Why is it not advantageous to keep satellites in the Van Allen belts? Because they last less, and therefore you have to place them either before or after. Otherwise, things don't work. And who and what kind of satellites are they? They are GPS Global Positioning System satellites, or Galileo, the system for satellite positioning that we all use, for instance, to operate our satellite navigators from Galileo, which is the satellite, the European satellite system, and other GLONASS. And there are many others. In short, each an important block of the planet, yes, builds its own satellite positioning system. Then finally we have the farthest orbit, which is that of 36,000 kilometers. So we are well beyond the Van Allen belt, where usually one orbit of the satellite coincides with one rotation of the Earth. So to an observer on Earth, the satellite appears stationary, but it is not stationary because it rotates. Which then, in reality, we will see that it also forms other shapes, similar to figure eights. So it is not difficult. It is very difficult to keep the geostationary satellite still, which then there is an international organization called the International Telecommunication Union, the so-called ITU, which assigns to the countries of the world the so-called box where the satellite must be placed for telecommunications. So we have telecommunications, telepositioning, and then in the end, the closest orbit is remote sensing. But it's not exactly, because lately the low orbit is, from my point of view, the most massively used orbit, because recently other satellites are also being placed there, namely those for telecommunications and also in low orbit and the internet service. So we can say that the low orbit is very important. It is an orbit that it is very important because there is a distance from Earth that is very close. It goes... All right, so now let's see why it's called a synthetic aperture radar. Well, first of all, as the word itself suggests, radar is radio detection and ranging. It's a device used for detecting the objects that are far from it, and then simultaneously measures their distance and over the years. So we say that this equipment was thought to be realizable at the beginning of the century because it was thought, well, then we can use electromagnetic waves to understand if there is something in front of us. For example, peilanpitas, pottas ankenta. It was certainly needed by navigators, and after the sinking of the Titanic, it was essential for ships to have radar on board, because it is important when sailing in the fog or sailing when the weather is bad to have the radar on to understand what is in front of us. The problem is that it took a lot of time and many years to develop it because in this case, let's call it the received power of the radar signal falls off with the fourth power of the distance. And this is a problem. It means that if I transmit, for example, 10, what I receive is 0.001 in terms of power, so a problem. So it took a long time. Some gentlemen had to invent special valves called, or TVT, called magnetron, which had the specific function of generate coherent radio frequency energy, and then this energy also needed to be high power. Okay, as the years went by, the idea was to try to install radar on board satellites. To do what? To consider generating electromagnetic images. So one was faced with a fundamental concept, a concept of physics, of classical physics itself, which was, in the past years, it was encountered, for example, with telescopes to visualize targets, the targets that are far away. It was necessary to act on a parameter, fundamental. This parameter is spatial resolution. This concept, and I'll also give you a scientific definition of spatial resolution. The spatial resolution is a distance, and it is a minimum distance, so that two objects can be distinguished separately. That is, if I have two objects,
These two objects.
if I make these two objects travel in the distance, and let's keep in mind this concept of distance, because we will find it later in synthetic aperture radar at a certain point, and we observe them with anything, with a camera, with a photo camera, with anything. At a certain point, we will no longer recognize these two targets as separate because the distance is too great.
And so,
Installing a radar at 600 kilometers altitude, you had to pay attention to the resolution. Physics tells us that the spatial resolution, the slide says lambda, the spatial resolution measured in meters is equal to, it is delta, which is equal to lambda times r divided by twice the aperture. Lambda is the wavelength of the parameter of the physical manifestation that I use for remote sensing. I can use anything. Electromagnetic waves, so the entire category of light up to gamma rays, electromagnetic waves, acoustic waves, hence matter. Matter also has a wavelength. De Broglie told us that in the times of quantum mechanics. Or indeed I can use, for example, electrons.
In the irony.
For example, when we have to use the electron microscope, electronic stands for electrons. So divided by 2, you see that lambda and r are in the numerator. This means that the more I increase r, the larger delta becomes. However, I need delta to be small because there is a minimum distance to ensure that two objects can be distinguished separately. Divided by the aperture twice. I have it's all about that. The aperture. If I have a camera, to see the details well, I need to have a camera with a large aperture. Why do I have to? I need to have a broad vision of this thing, wide aperture. Try, for example, to take a photo with a camera without a lens. It can be done, but what I get, it's something that is not the photo. I hope to obtain something, but it's not the photo. I absolutely have to insert the lens, because the lens allows me to see things the way we are used to seeing them. That is, after a Fourier transform process. What is the Fourier transform? The Fourier transform is that mathematical operator that, professor, excuse my term, it transforms everything that is a wave into particle. Because we are used to seeing things compressed. We see this pen because we've done a Fourier transform operation. Our eyes are moment by moment calculating a Fourier transform. So, to mount a radar in space, it was necessary to design the system with a large aperture. If you do the calculations for this aperture, then using the inverse formula, suppose, for example, we set a spatial resolution equal to 1 meter, you see that the aperture I must have in space must be very large. Kilometers, 20 kilometers, 30 kilometers. This means that it was necessary to install in space an antenna 20 or 30 kilometers long. Yeah? An impossible thing. It's not possible to carry out, that is, assemble a piece of iron 20 kilometers long on a space vector to then position it in orbit in space. Well, at a certain point, there was a period, for example, in the 1950s, when this project was set aside due to its unreal unfeasibility. It's not possible.
And how do you do it?
And it is done like this. There was a person called Carl Wiley, a scientist who worked
For Bell. In the United States,
whom I define as a heretic. There is always the clash between orthodox thinking and heretical thinking. If you look back in time and analyze what happened over time, when we all analyze it, we discover that heretical thought always wins. It always wins. So heretical means arrow, arrow, air, freedom. What did Carl basically say? He said that it made no sense to install a 20 or 30 kilometer antenna in space. It was stupid, it was useless. He said, cut a piece of this antenna, for example 6 meters. You cut it with the grinder, take the grinder and really cut it. Then take this piece, this fragment of iron, you package it, put it in the vector, and throw it into space. Then the orbit will take care of synthesizing what we want, even 80 kilometers of antenna. We will see that we have used, and here I take the opportunity to thank the 2 American providers who provided for free, not only to us, but to everyone, to the entire scientific community, to all people. They provided us with satellite data freely, with an aperture of 80 kilometers. An 80 kilometer aperture means a spatial resolution on the ground of about 6 or 7 centimeters. Very good. A very good resolution. Okay. So you see, the orbit, or in this case, the airplane, takes care of it, but it doesn't matter. One can imagine a satellite flying in space. And here I tell you that the satellites for remote sensing usually travel in a circular orbit, South Pole to North Pole, South Pole to North Pole. And then the Earth rotates beneath them. Below, the ecliptic remains constant due to geodetic physics. South Pole, North Pole, and therefore the Earth rotates under them. The satellites are able to take a picture of any point on Earth at least once a day. At least once a day. So they are very, from a scientific point of view, they are very appealing. Having overcome the problem of the opening, in this case, we perform time division scans. In the same way, it is synthesized, synthesized virtually, but really an aperture, as long as we want, even 80 or 100 kilometers, doesn't matter, because what interests us is having the maximum resolution on the ground. Okay, so what does the satellite do? The satellite, I will try not to go on too long because I imagine it would be tedious, but I will try to explain it simply so we can all understand how it works. And practically, what does the satellite do? At the moment it performs the scan, let's call it in the direction of the orbit, and we call this orbit direction azimuth. What does it do? It transmits electromagnetic pulses to the ground and receives the echoes. Receiving these echoes, they are digitized and stored in the onboard memory. Then, when the satellite reaches, for example, a downlink point, throws the data to the ground, and the data is then distributed to people. Usually, these data are not usable directly, but they need to be processed to obtain an image. For example, look, see this little machine here. Look, as the satellite traverses its orbit, you see the waves it transmits being compressed on one side and expanded on the other. Now this effect is called the Doppler effect. And just to understand for everyone that the azimuthal part of the image is synthesized with sounds. Because by chance the Doppler band falls exactly within the acoustic band. So with Professor Malanga, acoustics, we focus our efforts on this acoustic word. Why acoustic? Because we were interested in looking under the pyramids. And we all have to understand that the electromagnetic interaction with matter is only superficial. Miracles cannot be performed. Yes, I could be able to transmit 1 gigawatt of photonic energy and maybe achieve 20 or 30 meters of penetration, but forced into the material. Yes, but who would give you 10 gigawatts? It's impossible. So we thought of exploiting and acoustic energy to harness the phonon. Why? Because sound, the physical manifestation of sound, which is nothing other than the vibration of matter, propagates very well indeed in matter, and the denser this matter is, the higher the speed of sound propagation. So granite is just a perfect match for sound. And this is important. This is the synthetic aperture radar. So it transmits signals, the so-called chirp signals, made this way to resolve the range dimension, while in the azimuth, you see, or rather here, we have the Doppler effect. So, it has happened to all of us that we find ourselves facing a car coming towards us while driving. Maybe it honks. When the car is nearby, is approaching, the horn compared to its Doppler zero, therefore to the frequency for which the horn was designed, has a higher frequency. Then as soon as it passes beside us, we hear its original sound frequency, and then when it goes behind, the frequency lowers. So this physical phenomenon helps to solve the other dimension of the image. All right, and here, let's say, for me it was important to try to explain this thing in simple words. See here this diagram. Here we have a satellite radar. And this is the drawing of TerraSAR X, and it is a German radar, very good. You see, it flies along the orbit, and let's assume it has to take a photo, capture a photo of these three houses. What we receive, you see, are these echoes. These are the radar echoes. Do you see? These are the data we receive. And these are the only ones. It's not like we immediately see the images of the houses, eh? They need to be processed. Why? Because this image you see is like that photograph I told you about, taken without the lens. Because here, we still need to perform the Fourier transform. And how do you perform the Fourier transform? You see, it is done like this. You take the transmitted reference signal, the so-called sharp signal. The convolution integral is done with, let's call it, the distant part of these large droplets that are here. See? And we are doing what is called range compression. So we are trying to resolve the first part of the image. You see? Then we compressed the first part of the image. Then, by taking the reference signal, that is the Doppler frequencies that we have received, we obtain the three objects. So we moved from a wave situation after a Fourier transform process to having the particle. The particles are well defined, localized in space-time, because the localization is always done at 0 Doppler. This is an important parameter. Okay. See, this is another example of focusing. You see, the objects that are displayed not as dots, although particles, they are displayed with a particular function, that is the cardinal sine, which is the sign of x over x, the so-called sync. This makes us understand another very important concept that Professor Malanga has stressed, I don't know for how many years, in trying to explaining precisely the difference between territory and map of the territory. So human beings who are here, it will always be impossible visualize the territory. But what we also see with equipment, in this case with the radar, is always a map of the territory. That is, this means that our map of the territory is this sin x over x function. This since we will never see a dot, but we will always see a function that approximates the dot. Okay. Here, we can move forward. This is the part of focusing both in range and azimuth to obtain the satellite image. And then finally, ladies and gentlemen, to the function, to our function. Bidimensional scene of x over x, where we have the resolution values in the range and the resolution values in azimuth. We have finally obtained a satellite image. Well, I'll show you some applications of synthetic aperture radar. For example, it is necessary to mention what is currently state of the art. What is the use of employing synthetic aperture radar for synthetic? We use it extensively, for example, to carry out control or monitoring of the territory. No, it is very important. Why? Because the synthetic aperture radar has a very precise high. It has sub-millimetric precision, meaning that if I position the radar in space and look at an object on the ground, if this object moves slightly, very slightly, the radar notices it. The radar is capable of appreciate sub-millimetric movements of the objects that are on the ground. I'll show you this very simple video, very short video that...
we are simulating an interferometer. We have two coherent electromagnetic sources, you see. We are generating coherent electromagnetic energy with a first radar. With the second radar, you see, what do I get? I get an interference pattern.
Constructive interfering. That is, we obtain areas in space where the electromagnetic power density is zero, destructive interference, and areas where the power density is very high.
Constructive interference.
Okay. What do we need this for? We need this for estimate.
See? When I use two radars, for example, I can estimate the so-called interferometric fringes of the Earth. The interferometric fringes help me to estimate the Earth's topography in the 1980s from the shuttle's SRT mission. This is very important. The topography was made, thus drawing the topography for the first time of the entire Earth using synthetic aperture radars, a so-called interferometer that was mounted on the shuttle. What do we use this for? This, for example, this technique could be useful for us. It could be useful to us. Well, the video isn't starting, but that's okay. I'll describe it to you verbally. To estimate the ruptures of the Earth. The Earth's ruptures are estimated for measuring, for studying earthquakes and the movements of the Earth. Okay, so here we then move more precisely to what we have done on this project. So, on this project I will briefly describe how to transform photonic energy into phononic energy. This is important. So, with the Possassi professor we realized that any photograph, whether taken with cameras or with synthetic aperture radar, the imaging is not perfect, it's always blurry. Always. Why is that? Because everything moves. Perhaps it's not easy to see with a camera, but the radar, as I mentioned earlier, since it has a very high precision, very high, it is able to detect sub-millimetric movements of the Earth. Okay. So what did we do? We came up with a method, the so-called method of the Doppler sub-apertures, where we did not use the entire orbital synthesis to generate an ultra-high resolution image. That was of no use to us. So we tried to see successfully what would happen if we gave up a little ground resolution. For example, I give up half the resolution, I look at things with less detail, not, it doesn't matter. But, and then synthesizing the images, for example, we'd have bandwidth, we'd have Doppler bandwidth, we'd have orbit, and then performing a scan over time in the orbit. This helped us to demonstrate that it is possible to transform an electromagnetic wave into a phononic signal, because when we perform the intraorbital scan and by applying pixel tracking algorithms, we noticed that this pixel moved in a way that was consistent with the Earth's movement. Everything moves. This movement, that estimation of this movement applied to the pyramids, where we already knew the pyramids were moved, were put into vibration by the wind, primarily by human activities in Cairo.
Per second, and also
from a very important phenomenon, and that is the photon-phonon interaction that has the matter. In the sense that the synthetic aperture radar transmits electromagnetic pulses to the ground, a part of these electromagnetic pulses returns to the receiver, another part is transformed into phonons, very valued, because we realized they maintained coherence, they maintained the coherence of the transmitted signal. These phonons went underground, so they were quote-unquote reflections therefore returned from what they encountered underground, and we detected them again in terms of evanescent waves on the surface of the Earth. One thing we didn't, we were like this, and it was visible. So, by detecting these Doppler anomalies, understood to be evanescent waves that were visible on the Earth's surface, what did we do? Well, in this case, I always like to say this, that we designed a space turntable where the stylus, that is the record, the vinyl, is the Earth, the turntable stylus is the electromagnetic wave. It's the light. It's the light. The photon-phonon interaction is the needle. That is what transmits. It is the interface. What transmits, what modifies exactly the information from of one nature into information of another nature. Okay, and then practically our appetite grew as we started. So practically we didn't immediately start looking underground. Let's try to understand what happens. Let's try to understand the scale we're talking about. How much the vibrations we estimated were robust. So here I will show you, for example, the vibrations we estimated on the high voltage cables that we detected from the radar. You see these high voltage cables. Because the high voltage cable, I don't know if you've ever noticed, if you've passed under the high voltage cables, you hear the ripple of this signal of these cables, because they are set in motion by the high voltage, which makes them vibrate, and what we hear is the noise. So we captured this noise from the radar, so from the space, okay? And then basically after we did these experiments, we said, Corrado, here we need to try to develop an algorithm to perform the so-called tomographic inversion. What is it? Tomos means slice. If we have had the opportunity to estimate the evanescent vibrations on the Earth's surface, because no, then it was possible to look underground because mathematics says so. So you see, this is a model that we have We have sized like springs. You see springs, and with these springs, masses were attached. So the springs that vibrate attach to masses by performing the Fourier transform of the phononic signal. I have recreated the lens that allowed us to see underground. Okay, I'll just suggest something from the past that we did with Corrado, but only to reiterate the fact that that I respect very much, that he did us a great favor despite not giving he did us a tremendous favor because he validated our technique since the Scan Pyramid project months after we had already published the presence of the famous corridor, the corridor nicknamed the Corridor of Discord. He supported our theory, so I am very happy, and I thank him because he actually helped validate our technique. Okay. I apologize if I am a bit tedious in presenting the formulas, in perhaps explaining things to you, but unfortunately, we all need to understand them together, so at least we feel more assured. I'll just show you a couple of examples where we applied the synthetic aperture radar technique, phononic version, to observe, for example, large infrastructures that we have in our national territory, like the Gran Sasso Laboratory. So, the Gran Sasso Laboratory is a physics laboratory located about 1,400 meters deep of depth, if measured from the peak of Gran Sasso, then from Cono Grande. From the peak of Gran Sasso. And you see, this photograph is the, let's call it tomography that we estimated. It was one of the first tomographies that I always like to show because it is beautiful from my point of view. It is beautiful. I would say it borders on Bazinga in this. Joking aside, we managed to see the INFN, the National Institute of Nuclear Physics, hence the Gran Sasso Laboratory, with sections of the tunnel. Here it is. This is an enlargement. You can see there's the interferometer too. You can see that in the end. That point you see at the end is an interferometer, and from here the interferometer always returns. We are coherent living beings. No? We are coherent. We live within domains of coherence. Our mantra is coherence, so it is resonance. But physicists also have it, rightly so, because the interferometer cannot function in an incoherent situation. So there will always be lasers that generate coherent light and then mixed right into constructive and destructive interferences. Okay, all right. I'm in a hurry because I'll then give the floor to the professor. I'll just present another case study. So this is I'm presenting the Mosul Dam, which is an enormous dam. We wanted to understand if it was possible to look inside the dam. You see, the dam has a large tunnel inside. It has a big tunnel and an important Italian company, Trevi, Italian Pride, it was commissioned by the government of Iraq to carry out, but it still goes on, the consolidation of the dam. Because the dam is gradually falling apart, it is collapsing and needs continuous maintenance. In short, inside the Mosul Dam, there is a tunnel, the so-called service tunnel. And you see this. I present to you the tomography of the Mosul Dam. And you can see the section. And the darker section, this one here, more blue horizontal, is the tomography of the gallery. Thus, the section of the Mosul Dam, where you can see the gallery. But we had noticed that it wasn't just visible, the gallery. And other nice things could be seen. I wanted to show you them. You see how we came to see the area of the turbines. So we managed to take a picture of the turbines of the Mosul Dam. Because the Mosul Dam, besides holding back the water and thus creating the reservoir for water accumulation for AGA, for agricultural uses, also carried out the generation of currently generates electricity by means of hydroelectric energy. Okay. So we took the image of the turbines. Okay. These are other turbines that we have seen. You see, this is just to show you that it is possible to view the area, let's call it technical, which is inside the dam, inside the energy structure of Mosul. Okay, one last case study is that of the San Gottardo tunnel, and so we did, we generated the image of the subsoil of the San Gottardo facility. And as you can see, you see the tunnel that is inserted into the mountain. This is very nice. I like this one. Here it is. This is the tunnel, which is located really many meters deep indeed. Okay. Just to say then, this method has been submitted for a PCT patent, so an international patent currently active in Malta, this patent. Let's see a bit of the future. What does it?
Will you wait? Okay, I'm done. I'll turn it over to the professor. Thank you.
Here we are. So, the tip of the iceberg. The tip of the iceberg, because essentially we realized we were really analyzing the tip of an iceberg, because our idea was to go and see in the pyramid of Khafre, Khafre. And the idea, it started right from Armando Mei, because when we talked about it, our idea was to go and see under the Sphinx. And Armando says, yes, under the Sphinx, but we know there are chambers, things, it is not said. People do not talk about it, but there are data indicating there is stuff inside. Wouldn't it be more interesting to look under the pyramid of Khafre? Because under the pyramid of Khafre, there will be something below, inside. And the myth, the legend, the stories say that this pyramid is linked to a whole series of things, as he said before, that should somehow be proven. Because inside, there's a bit of the story of the god Thoth.
And we said, well, come on, let's try, we're there.
The radars, we have the radars. Let's see what happens. A recap of previous episodes. This was basically Khnum Khufu, the one protected by Khnum. You see, on the right, you can see the section of the pyramid as we know it with a superimposition of the dark black three-dimensional outline of what essentially says that it is inside. You can glimpse at the top that kind of strange multi-level structure with chambers called the Z,
with a chamber underneath where there is the The tub, where some mistakenly think the poor pharaoh would have been. The Grand Cancaleri, which is that sloping, tall, large black thing that descends. Below, we have that small little house, which would essentially be the queen's chamber, which we then discovered with a couple of books that, with the queen, it has nothing to do with. At the bottom, there's the unfinished chamber. We've always wondered, it took them 4,000 years, damn, to finish a chamber they could have done earlier. Seems like they didn't feel like it anymore. Who knows? And to the left, up and down, a couple of photographs of the three-dimensional model that we proposed in the article in remote sensing that shows things that no one had ever seen before. At the top, you can make out those kinds of gadgets descending like a giant fog going below ground zero, meaning underground. We'll talk about this more today because we've seen this stuff again from another perspective. There are these structures that instead go up into the pyramid, which are connected by a gallery that I usually color red or anyway light brown. You know, I don't see colors well. So below, from another viewpoint, you can see essentially at least 12 rooms underground that we have called the basements. Evidently, the pharaoh did not want to pay the property tax, did not want to pay, and he hid them beneath, never reported them. And there is a whole series of structures inside that we can see both essentially in the second book that I wrote with Filippo, where there is essentially also all the technology that Filippo has somehow described to you now. Let's look at the state of Khafre. You see a three-dimensional model. What is known, we see from above on the left. We see it from the side, in the center, and an enlargement of the latter. As you can see, the pyramid is empty. There is nothing inside. Below, right under ground zero, and this is what we see in this enlargement. There are essentially two tiny rooms, a couple of corridors with strange shapes on which, on these shapes, we have already focused our attention in a previous conference where we showed how everything we imagined for the pyramid of Khnum Khufu, meaning that the pyramid functioned with vibration, an instrument made of water, with rock, essentially, and with air, and that it produced those necessary vibrations that were used to heal, in quotes, the pharaoh when this had reached the final moment of his life, and this life needed to be extended a bit. And as you can see, there's nothing inside this damn pyramid. Is it possible, we wondered, that the ancient Egyptians spent a ton of money to build a mountain of stone with nothing inside? And so we had to go and see. And we started to apply this technique, that is the transformation of a photonic signal into a phononic signal. We look at the vibrations. We take a photograph of the sound of the pyramids. So, this is a photograph as the satellite's eye would see the pyramid in question. As you can see, this photograph has a characteristic. It is not how we would see it with our own eyes if we were on the satellite, because it has strange light points that are not quite like the ones we will see, and then it is elongated. It looks more like a rectangle rather than actually a square. And we need to understand this thing. Why the satellite sees the pyramid in this way. Pretend that the satellite antenna, for simplicity, is a rectangle. This is the antenna. So the satellite does not have the antenna straight, perfectly aligned with the sides of the pyramid. The pyramid, imagine, is straight like this. The satellite is tilted in this way. And not only on this axis, but it's also tilted on this other axis.
So what happens is that when the signals that will then originate this type of photograph are brought back, the signals are distorted by the fact that this antenna has a position that is not what we might choose in some way to see the object perfectly along the x-axis and along the y-axis. The tomographies we will be doing have the same problem. That is, they have an issue where you need to know they are photographs distorted in this way for this reason. Well, once you know it, the problem is gone. One of the first tomographies we did was this one you see on the left. So let's retrace the story a little with these tomographies, how we experienced it in some way. The first photographs, we looked at this stuff, went to bed, couldn't sleep, and looked again the next day, hours in front of these tomographies, to understand what they meant. And here is an important detail that I believe is worth to note. When we conduct research of this kind or any other kind, there is a conscientious parameter that basically you never write in the books. You never say, my consciousness has increased by 3 or 4 degrees at the moment I was doing this research. When does consciousness increase? Consciousness increases when you look at the nail in the wall so many times until you realize that there is a nail in the wall. And so, in looking at these photos, these tomographies, a spontaneous process of gaining awareness arises. The first time you look at it, you don't understand anything. So you see here, yes, you see there's a triangle, and you say, oh, you'll see it's the size of the pyramid. Whoa, you see it has different colors. You say, well, okay, because energetically, the pixels corresponding to this photograph vibrate differently. The energy put into play, the computer, the software, marks it for you as a different color. All right, fine, we agree. Then you start to see a strange color tube that descends to the center of the pyramid, which seems to be made in layers somehow, and to which the other corresponds towards the center, to a kind of tube that rises colored in another color, and you say, bah, what is this stuff here? Technically, there shouldn't be anything. Then something else is done.
You take images like this, which is a starting image.
Yeah, where basically it's a north-south image. That is, you have to think about entering into the image you are looking at. That is, you have the entrance of the pyramid in front, the enters in front, and the section we made in the middle of the pyramid is like cutting a cake. Well, you see that cutting this cake is not that simple, because you cut a cake and see the layers of cake, cream, chocolate, everything that's there, candied fruits. Tomography has a series of things that make it incredibly complicated. But this complication, a scientific term you'll see, gives you more information because it's complicated, as there is a lot inside you. And your awareness in analyzing the various tomographies must be able to discern all these things that are there, because tomography is a phononic photograph, meaning every pixel of that strip that we have calculated feels the vibratory information of all the pixels that are in the strip. But not only because it feels, because this pyramid strip senses all the information of the things in front and all the vibrational information of the things behind. So this photograph not only tells you what is in this section of the cake, but also what is inside, in front, and behind. And only by knowing this thing can we go looking for what the slice we have cut contains, trying to understand what has nothing to do with this vibration, because it actually relates to vibrations of things that are behind and vibrations of things that are in front. So while this tomography. These colors of this tomography represent the fundamental data of the energy of the pixels that move, so the frequencies that they move. So we can immediately say that the external part of the pyramid vibrates differently from the internal part because the colors are marked. With this system, we tell the computer to show us these strong differences, and it shows them to you. Because if I tell the computer to show me differences but delete some signals because I don't want to see them, the computer shows them to me. That is, the computer applies filters to me.
Applies, removes, but does not alter the relationship that exists between the different things.
On the other hand, the photograph is another thing. You take the tomographic image on the left and tell the computer, since I didn't understand anything, help me highlight some vibrations in the form of color while others not. What does it mean? It means that I am helped to understand some information, but others on the right side sometimes get erased, exaggerated, while the true information is what the computer gives me on the left side. Let's keep in mind these two methodologies because we need both to then understand and interpret the tomographies. On this side, now that we know it, no, on the right side, we see that the bottom part, that is this kind of cannon that goes down, really seems, and there I can assure you we didn't understand a thing. Why? What is this thing here? Bah, it must be a reflection. Maybe the technique isn't working. We'll talk about reflections later because here, like an optical physical image, it has reflections. The sound image has echoes, as if we were in this room and there was an echo. What is an echo? A reflection that instead of being luminous is a sound reflection. And here, since we are working with sound reflections are present. So it made sense to see things that didn't actually exist, that were ghosts. So we say, wait, let's change position. Look somewhere else. Here's the fundamental problem. If I have to build a three-dimensional model, I can't see an object from just one photograph. I need to scan at least from two positions, but maybe two aren't enough. Let's say three, X, Y, and Z. And then we asked ourselves, having the starting image in front, from the other side, let's say the Russian side, to be clear, right? The American side, the Russian side. Because the north is at this point of the pyramid that we are looking at. The entrance is always to the north. On the Russian side, what do you see? You immediately see something fundamental. The two sides of the pyramid do not have the same slope. For what reason? Because these two sides of the pyramid are not the two sides we saw like this before. When we turn the pyramid this way, we see on the left one side, on the right, so side one on the right, side number 3, because side number 2 is in the middle and cannot be seen. And this time, that thing we saw as something that went from the bottom to the top, reaching the apex of the pyramid, is no longer just one thing, but many things. In this thing, 1, 2, 3, 4 were seen and a little behind, maybe 5. What do you want it to mean? It means that when we saw the tomography that we saw before, all these things were there, but they were one behind the other. When we moved, now we see them not one behind the other anymore, but they still occupy a precise space. So, another issue of the tomography is that the tomography is processed with a scientific technique called the Tripa effect. That is, the Tripa effect. What does this mean? It means that once we have the tomography, we can enlarge it, squeeze it, because the data is not altered. We know that a pixel, which should be a small square, we have turned it into a small rectangle, but we know this. instead of having 20 small squares, there are 20 small rectangles, but we know that we have squeezed it. So why is it done this way? Because we try to understand in very large tomographies, focusing on highlighting a part of the tomography while the other part is not of interest at that moment. In this context, the tomography we see, basically you see north-south, I wrote them, to show how we arrange things. And what do we see? We see which above, firstly, we squashed it. So it's no longer a pyramid like this, but it's a pyramid that is practically almost a line. But in the middle, we see colored spots. I see them orange. I don't know what color you will see them. We see two very large ones. Something in the middle, maybe behind the large spot on the right. There is another spot that might be behind. In the center of these spots, there is definitely something, and to the left, there is a small spot further away down there. And we begin to see that these spots have a structure because we have brought them a bit closer. We performed a better Fourier transform. We have somehow brought it into focus better these things. How do you focus this thing? It's simple. You take many measurements, many images, tun, 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 tun. What do all these images do? They take the background noise and they kill it, because in an image, since the background noise is chaotic, in one image it can be positive on that point, on that pixel. In another image, it will be negative. And so in the end, the background noise is killed. And what remains is only the signal. You see, if Fourier didn't exist, we wouldn't be here today. Absolutely. I have been to Fourier's grave in Paris at the Père Lachaise cemetery, it is called, and I discovered Fourier's grave. I mean, I started crying over Fourier's grave. And we, looking at this thing, start to see that at the top, in the central body of the pyramid, there are these spots, there are these objects. At that moment, Filippo and I looked at the bottom part. Whether at this are these strange things coming down, it says, they are reflections, they are errors, and damn it, maybe who knows why, but we will understand. We need to do other tomographies. And we understood it well, of course. And so we did the other tomographies. This is north-south, so this is east-west. So look here. We have this. What could be the disadvantage of, as I was saying before, when doing a tomography, having everything stuck to this plate in front and everything behind it? If you notice well, when the radar is not the antenna perfectly parallel to what we want to see, but is tilted, it's the same. It's as if the antenna was straight and the image was bent. That is, it's as if we were seeing an image in 3 dimensions. Fictitious, because we see a fake 3-dimensionality. And if you look closely at this image, it's true that at the top we always see 1, 2, 3, 4, 5 things. Then behind on the left, there are some other little things that we don't know what they are. And on the right, something very confusing still. But if you notice on the left, it's as if we see one side. Now I'll show you better. One side of the pyramid going in a certain direction, the vanishing point, and practically the plane of the pyramid that should appear as a straight line actually appears as a real plane. Sure, there are always these darn things coming down, or who knows what they are, and then they are basically all, in some tomographies you see them better, in some tomographies you see them worse, but this depends on the fact that we wanted to choose a setting that highlighted the top part in this context. This is essentially the plane that the human eye, at the level of awareness, makes you understand. So look, there's stuff above. And damn it, there's stuff below too. It's probably the usual reflections. However, one starts to see a structure of something that no one had ever seen. Inside the pyramid of Khafre, on the upper floor, there are things that vibrate in a different way. How many of these things are there? If you look on the left, there are two very prominent ones. There's something towards the center, and there are at least a couple more towards the right. Then there is, to the far right, a very precise structure, and then the rest seems to be underneath.
But it will be, one must be careful, one must have, well,
is the possibility to see things better. So we need to increase awareness. Let's go see these big structures, try to understand how they are made. Why did we count those immediately? Because they were the ones that were seen better, meaning the ones with fewer errors. They are the biggest. And let's look in front and face, as they say. And in this context, keep in mind that in this chromatography, you enter from the right. The entrance of the pyramid is from the right. Then you descend below, where Belzoni's chamber should be somewhere, which is not visible. And then I'll show you why it's not visible.
And everything you see is stuff that's on top.
In front, there are two things that seem layered. Do you see them? 5 layers with a kind of roof, a bit like a pagoda. Behind the one on the right, you can see there's another one that's very similar. But behind the one on the left, you can't see anything. However, in the center, you can see there's another bright spot. Let's go take a closer look. We'll get some help from the computer. Can you show me better if you can, dear computer? Can you highlight some parts of the structure?
And here,
it occurred to us that maybe we had already seen these structures. Look at the structure on the left. 1, 2, 3, 4, 5 levels, and then a roof. Let's call it that for now. A hut. Underneath, you see there is a little square, a bit darker. This reminded us a lot of something. Now you can also see on the right side that there's roughly the exact same structure, and behind it, if you notice, there's one that looks a lot like the one in front. Let's take a closer look at it. You see, I also included the RGB graphs of the colors blue, green, and red because we processed only, in this case, one type of color. You see on the left side at the bottom, I made a little circle with a question mark. Do you see that it looks like there's something in there? But what the heck does this stuff remind you of? Let's look at it again from a distance. You know, the map of the territory, when you don't understand something, you need to step back to try to see and maybe understand this. Maybe it didn't look like this, but we had already seen this one. Filippo also showed it to you in his presentation. It's a room with the letter Z on it. And look, maybe inside the room on the right, sorry, on the left, maybe there's a strange spot that who knows, maybe it's something, we can't figure this out because we sacrifice half of the radar synthesis to use the other half of the synthesis to obtain the colors, let's say, of this tomography. How many of these things are there? It seemed there were 5 from all the tomographies. We necessarily had to see everything from above, because from above it would be clearly visible. We cut the pyramid horizontally so we could see, hopefully. How many of those things are in there? Here, on the left, we have the photograph of the Khafre pyramid cut in half like a sandwich. And you look at it and don't understand anything, and you tell the computer, then show it to me better, because damn it, otherwise. And so we get the view on the right, and I'll show you something right away. Actually, I will show you 2 or 3. They are luminous things
that run along the left edge, at the top and on the right. Luminous things. There is a spot. Bottom left is a spot. And what on earth is this spot? We will figure this out easily. However, there are things, and these things fall into two categories. Those that are hard to see, those that are easy to see, but they are all there.
The stain.
All right, the phononic light spots. You see, these are somehow illuminated pyramids from the outside. Look, these are phononic light spots. That one, in particular on the left at the bottom, is exactly what happens in our tomography, where sound creates a reverberation. This had already happened to us in the pyramid of Khufu. This reverb, you say. Damn it! There's a reverb that blocks all the information there, and instead it will give you information, because every time we do a chromatography and an analysis, a tomography from above, we can immediately orient north and south without much hassle, because the spot is always on the same side. A phonic spot. So we take all this data and put it all together. All the bright spots in all the tomographies must always be identified. They must always be the same. From above, we start from above. You see one fundamental thing. The center of the pyramid is not, as you might expect, in the center of the square of the topography, but it's shifted. Why? It's simple. For two fundamental reasons. One, because the radar, it is distorted compared to the image of the pyramid. And so, like in the photograph that seemed like a truly optical photograph, it stretches the pyramid in some way so that it is no longer a true square, but becomes a rectangle. So one part of the pyramid has data closer together. The other part of the pyramid has them a bit more spread out. And so the center is where Belzonian chamber is. And you see it, there is essentially a small rod. Then there are four structures that are those four little circles that you find in all the tomographies we have seen, and that from right to left, from north to south, from east to west, are always the same number. You understand exactly what the position of these circles is. And kinky shan, kinky end. You also understand why they are seen this way. So when we have built a three-dimensional model with the three-dimensional model in hand and the tomography on the other side, you tilt the three-dimensional model to achieve the same optical effect as the tomography. And as you can see, now, if it's not simple, it took 3 months, maybe 4, that is, to recognize all the bright spots in the structures that we saw in the different tomographies.
It is evident that when we upload everything online in about 10 days, including this slideshow, you at home,
you can do the exercise of going to see, going back and discovering for yourselves if we try to trick you or if we have really used our time in some way and not wasted yours to understand exactly the points without wasting time.
Let's return here.
Now we know one fundamental thing. From approximately the center, two bright paths start very close to each other, originating from the spot somehow downward and not exactly at the center, but slightly shifted to the left. These two bright paths go upward. So, you need to remember what the pyramid looks like. Below, there are two pathways, an entrance that goes to ground zero, goes underground, and then ascends, and another from above. But these two pathways are one beneath the other, and the other then reconnects, and will reconnect at the end, before the Belzoni chamber, in the
final horizontal corridor.
These two objects, which you see one above the other, if the radar is exactly above, because if the radar is here, you see them side by side. This is why these two things seem like two paths to you while they are just one path.
After that,
there are brighter spots and less bright spots.
We will understand later why this happens. And you will understand that the brighter spots are brighter because there is something above and something below that evidently increase the vibration of that particular point of the thing. Whereas when there is nothing below, we only have, for example, the vibration of the thing above or vice versa. There is only something underneath and nothing on top. And that's when these strange bluish halos appear. Meanwhile, I've started to get the hang of it. They are close to the bright areas. They surround them somehow. But it's something that vibrates little. It's something that is barely visible. But the fundamental thing is, what is the stuff on the right? These two, at least two paths, at least two luminous paths, going from bottom to top. I just want to point out that if you look at these two luminous paths in the bottom right corner and slowly move your eye upward, you'll notice that occasionally the simplest thing was that there was a horizontal path. Trim, 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 as if they were from a comb. The petals, so to speak, the teeth of a comb. And if you look closely, I don't want to waste your time. You can do it at home at your own pace if you feel like it. In some areas of these vibrations, the combs, the teeth of the combs are evenly spaced. Who knows what it might be? What did Filippo do? I took the pyramid and cut it at different points, at different levels. Look at the top left. The pyramid, you always see the usual distortion of the pyramid, right? As the radar sees it. She cuts in position 1, in position 2, in position 3, and in position 4. Let's look at the tomographies at different heights. At different heights, it's like you're focusing with a different focal distance, because here, the more the image, the topography, gets closer to the object you are looking at, the more the focus increases, meaning the precision. In fact, and this is the first step, number 4 is much more precise, less blurred than number 1. In number 1, you can see these strange little combs, this time seen from above. But in number 1, there is less. In number 2, there is more. In number 3, there is more. In number 4, there is more, which is almost at ground zero. Keep in mind, I have to tell you this or you won't understand. This little square, no, the little squares we have here, 1, 2, 3, 4, don't correspond to a square because there's the Tripa effect, The side of the pyramid, the pyramid should be a square. And here, what you see is that the strip containing these strange combs is under one side, which is the side, the American West, in the pyramid. In this context, and the tomographies, you'll see that the light spot serves, entering from the left. The entrance is almost below the spot, and so the little comb is exactly under the ground zero, under the side at the end of the pyramid. So in this case, the tomography that interests us is only the top half. The square of the pyramid has become a rectangle. But this strange structure, what is this stuff here? We had to take a closer look. You see, at the top left, we have the usual spot. We know that the entrance of the pyramid is below the spot. Let's look at the worst case, because we are not interested in looking at what we saw before.
We want to focus our attention on that side there, this side where there is something flowing from left to right, and below something that looks like combs.
So what do? You apply awareness, which means you look at it until you've understood what it is.
So, obviously, there is an effect that some fool might call pareidolia, meaning at some point you see what isn't there. Know that what you see, you will be able to see again with the acquisition of awareness in all other chromatographies.
Tomographies, seeing them from other places, changing the point of observation, changing the map of the territory.
Let's take a good look at this thing up close. So, the top part shows you, I remove the colors because they essentially bother you. That is, they are additional information that is not needed here. When we look at this thing, you see I've oriented the little square of the pyramid's plate on the right, so that at the bottom you have the light areas corresponding to the things we are going to look at. At the bottom left, we see this luminous path made with tuning forks. They all look like tuning forks lined up. They appear shifted like this because the antenna, I remind you, is not aligned with the pyramid. It's shifted like this. So it's as if you had a straight antenna, but what you are looking at is shifted.
So this inclination is one that gives the inclination of the radar antenna.
Look down in it. Look carefully. And as you look, pretend that you understand they are tuning forks.
If we say that in Kasagichi there are disturbances, so there are lines going from left to right that are sometimes dark, sometimes reflecting light. Until one day, after months, I understood what it was about. And above, I'll show you the reconstruction. There are these combs that are basically tuning fork shapes. And in the middle, there's a sort of
rectangular shape
that the radar sees. Let's assume it is granite. The speed of sound in granite is 4,000 meters per second. It appears transparent to you. It appears like glass. So imagine having this thing with a rectangular glass rod inside. And here, the glass shows you the things in front in a certain way and the things behind distorted. And this type of distortion is exactly what we see in the end. In this context, only the acquisition of awareness makes you understand that things are this way, because otherwise you won't get to the bottom of it. What then, in the end, what is the structure that comes out of here? The one we see below. There's something running from left to right, 7 objects that look like tuning forks. And here inside the tuning forks, I didn't include it. But I'll show it to you later. There's another corridor, question mark, that is at the peak of the curve of the tuning forks at the top and travels the same distance from left to right. What the heck is a structure like this for? This is a question we don't know. Look, there are these structures, for example, these giant tuning forks, which could essentially be structures that simply serve to support something. To the left, just imagine, is the roof of a library located in a Dutch or Norwegian city. It is a gigantic library, probably meant for something else initially. Then they didn't know what to do with it, so they made a library. And over there is a structure that supports a dam. So structures like these exist and evidently have their own kind of use. But how strange. It looks like a tuning fork, just as we are looking at the vibrating stuff. Huh? How strange, eh?
Let's move forward. Let's move forward. Let's leave this thing pending for a moment.
Let's do another tomography. The other tomography is essentially south, left, north, right. And we see from another point of view that we are seeing only one side of the pyramid. That is the long, long, long one.
dragging on the ground the one that goes roughly from the center to the right, because we clearly have the impression that the other one over there, the one on the right, is instead much steeper.
Why does this happen? For the usual reason. The antenna, look, we have used different types of radar. So depending on the inclinations of the different antennas, you should not expect the same slope in all the topographies, because it is not like that. What do you see?
You see this and say, I didn't understand anything. The only thing you understand is that there is a pyramid that does this for the king, because you know it's a pyramid. Otherwise, you wouldn't even know that. So let's try to understand better. We get help from the computer, and immediately something interesting appears. In the top left, we see a black rectangle.
This black rectangle on the left then has a series of much clearer things that vibrate. Also, they have higher energy.
Dark black instead means it vibrates less. And next to the stuff, central on the left side, if you notice, there is a kind of small square the same size as the black rectangle that is less black. But it's there.
Let's try to bring it out better. If we go on to change the colors again, at the bottom we see the rectangle that was black before has become a color like orange-ish. I think you see what on earth color it is.
On the other side at the end, you see there is the square.
At the same height, of the same color, and in the middle you can see, but because now we know what they are, all the little dots that represent the 5Z structures, which we absolutely wouldn't know what they are if we hadn't done the other topographies.
But here you can see them, and if you count them carefully, there are 5.
Let's look at it even more closely. Let's search for the information. So we have a big black rectangle on one side and a big black square on the other. In the middle, the 5Zs. What could the big black rectangle be if not a place where there is absolutely nothing and therefore does not vibrate at all except for the air inside?
So there we have this big rectangle that probably isn't a rectangle, because we must always remember that the other side, the right one, appears to us as blurred, stretched, squeezed, tripe effect. So it may be that actually these two spots concerning the height of the two objects have the same height, because the error on the right and the error on the left in this case is roughly the same. But on the left and on the right, therefore not top and bottom, things are different, because one of the two sides of the pyramid has been extended.
Where are these objects? So the object that you see as the big black rectangle is the object located in the arrow at the bottom in the right topology. The object that we have already seen in the other topographies, you go back and look, and it's there.
Which is the one we identified with the arrow on the left.
The chamber, let's call it the smaller one, is the arrow we see at the top right, where there is this extremely bright area. I would like to point out that these two chambers are connected.
You see it from at least one path
that connects one side of the lower chamber roughly to the center of the upper chamber. You will see that this path is a split path. If you look closely, you will discover that there are other pseudopaths connecting the other spots.
Well,
and then there are the Zs. Here, these vertical structures are seen even better.
We had to do another topography because we continue until it is understood. So this time we look at the topography on the right. In the topography on the right, where do we enter? The pyramid has the entrance on your right, and you see a sort of darker rectangle where the far side is lower. It appears lower than the side that connects the far side to the near side. Let's notice in the middle there are some dark spots and a path that might be the path, one of the paths from the entrance towards the dark spot that, with a bit of imagination, could perhaps be said to be Belzoni's chamber, of which only the roof is visible. Then you look down and say, holy shit, those usual things aren't there going down. What is this stuff? Can you show it to me better? Here, if you look, there are things coming down, and they look like coilings, but basically, yes, coilings. If you look at them either on the right, then on the left, where we only have the staggered colors, we discover that it seems these objects are once again on two levels. If you see everything from a distance, the pyramid looks like a tiny pyramid with a spot descending in the center. When you get closer, you discover that the spot is actually two spots, one and the other. And if you look elsewhere, you start to see that there are objects one behind the other. And the first result obviously left us even more confused, because we said, hey, come on, let's take a look underneath. Because we had already seen that under the pyramid of Khufu, there were these two slides that went in and went down. Do you think there's something there? Anyway, we need to take a look, so let's take a look. That's how we discover that they are reflections. The pyramid is practically flattened at the top. And below, there are 8 pipes going down. 8 paths characterized. Remember the tripe effect. So you are looking at a pyramid that basically, once again, you enter from the north, and you see the two most important zid in the center, because they are characterized by a strong detection, a little bump on top that somehow identifies the roof. Look, the pyramid is squashed in this way, eh? So think that roughly we are looking from the start of the Z to the end and a bit above, meaning the pyramid's top goes beyond the topography, reaching a height of 137 meters. So we've compressed it like this. You realize that from ground zero to the ground, there's quite a bit of path. There's a lot of stuff. And how are these gullies organized that they descend? They are placed in 2 rows, see? The brightest and the least bright. What does the brightest and the least bright mean? It depends on the distance from the topographic plane and the vibrating objects. Let's assume for a moment that the objects are the same. If one is farther, you focused it differently, and therefore it vibrates in a different way. So it will be more or less bright.
Well,
they could be reflections, because up until the end, we said they are reflections. We need to try to understand. So we look at them more closely. We increase the resolution. We increase the number of accumulations. And what appears is this stuff here, where there is a row of these objects, 4 in front and a row of these objects, another 4 behind, and depending on the angle from which we view the topography, these objects that are all identical overlap each other, and since it essentially appears to us as if they are all behind, more or less opaque. You see that we highlight this opacification. All right. There are some vertical things descending, but what is that stuff spinning around us? That looks like a spring. And if we look closely, this spring, it does not always have the same inclination. It does not always have the same color. When a spring, let's take one of these traces, rotates around to this hypothetical object that descends, and it ends up at the bottom, we will determine how deep
You see that at the bottom there is a hard core where there are some things. The connection of this stuff above with the stuff below produces vibrations of different colors. Structures, there are structures at the bottom that connect this stuff, that goes down with the granite, which is probably that final part at the bottom that holds everything. We will need that to look again. Once more, we go back. Let's review the previous topographies. At the top left, see how these objects appear to you. They are all in the center and arranged in 2 rows. And the 2 lines, which you see the topography as we made it on the right, each of these centers corresponds exactly to one of these things that go down. And now it's clear what the light bluish halo we were seeing from above is. Something that it is not seen very well from above. Now, from above, the structures inside the pyramid are visible. But why are these structures? You don't see them well. They are blurred. We will discover it in a moment because there's something in the middle that prevents the vibration from coming up and being visited, seen, captured by the radar because everything must match. Let's watch. The 2 objects that go down to the center, do you see them? Because they are the brightest, so they will give us the most information. We subject them to color variations to try to make our eye grasp. Tinta, if not in the first, maybe in the second, maybe in the third, those details that then allow us to understand what we have in front of us. There is a conscious, mindful operation. And there we clearly see that there are things descending. But the slope of this stuff changes because when you see a spring in front of you, the part of the spring in front of you, all sides of the spring slope in one direction. The spring that is transparent lets you see the back sides of the spring. And the slopes behind are different. So maybe it's something that spins around something else. And if you look closely, you discover that it is not that this thing narrows in the center and widens at the edges. Because other topographies, like the previous one, show you that in reality, it is something that it has the same thickness. At any height, you see it. This kind of constriction is a problem related to vibration. We are looking at things that vibrate, so brighter things appear larger to the human eye, less bright things appear narrower. This does not mean that at that midway up, this stuff tightens. It means it vibrates less. We took one of these topographies. We removed one of these vertical things. We stretched it so that we could see it well and study it well. We asked the artificial intelligence to enhance the image. We improved it by 16%. We also tried to tell the software to somehow improve the understanding of the bright things that were there. And we see something interesting. We make 1, 2, 3, 4 sections of this kind of vertical stuff. That one at the first on the left, after the small image that represents the entire path, you see that the top part is essentially enlarged. For some mysterious reason, you can see about halfway that the outer part of this object is as if it isn't there. There's only an inner part. That is, there's something with something else inside. But how cool! Could this be why the brightness of the stuff coming down has 3 different levels of brightness? Look, this is not a trivial matter.
It could be brighter in front, less bright in the back. Of course, less bright in the back because there's the vibration that's absorbed by all the material of the vertical object we have in front of us. Instead, there aren't two types of brightness. There are three.
And this makes us understand something strange. We still had to look at everything from a more distant perspective. So what was done? At this point, it was said, well, let's move a little further away and look. Border from Titansia ka, Gistan is trying to fit the pyramid we are looking at into this chromatography, which is the one in the center. On the left, you can see Meikerinos behind. Keep in mind that the plate we made cuts the pyramid of Khafre in half. But you see, you catch a glimpse that the... you can see three sides of the pyramid. On the left, the one descending leftward. On the right, the one descending rightward. And in the middle, where there is this dark column, there are the vibrations of the other two edges that we have in front of us and that are behind the pyramid, because the pyramid is transparent. Why are these edges black, darker? Take a bell, which instead of being round is a square bell. You strike it, take a mallet and hit it, and the bell ring. But if you strike one of the sides of the pyramid, because if you strike the edge of the pyramid does not emit a sound. That is, we are looking at the edge part of the pyramid, the front and the back, that by not vibrating create a dark cone. Not black, dark blue. That's why there's that dark area there. I say this so we learn to interpret the tomographies as well. Sometimes at night you need to interpret. One might know in life, but what do you know? And while we look at this, we notice that in this tomography, now our eye sees the nail in the wall. It sees that even though we didn't purposely highlight the things coming down, you see them in lighter blue tones. There's something descending, and we now know they are not reflections. And then when we look down, still on the left tomography, we see at the bottom there is a kind of area that looks like a little rectangle, a little square with something bright inside. A little square, a flat surface, square or rectangular, with something inside that vibrates. Let's try to highlight this stuff. So let's do the usual color change trick. On the right, we see this stuff that vibrates. Here, with this system, you see two important things. In the small rectangle at the bottom, 1, 2, 3, 4, at least 4 of the 8 channels of these objects descending can be glimpsed. You can glimpse them because the terminal part vibrates the most because it is the brightest. As we saw in the other tomographies, everything must match. Yes, let's look at this stuff better though. Because actually, on the left, there are other things coming down that are confusing us. But what is that stuff there? Huh? All right. Let's try to change the colors. On the left, you see there is the square or rectangular spot, and you can clearly see 1, 2, 3, 4, 5, at least 6 of the tubular objects descending, and the brightest part is the one closest to the plate that we see. On the right side, I have marked for you with little circles the bases of the objects that descend. We needed to understand a little more here. First of all, this is roughly, approximately, the top part of Khafre's pyramid. I draw down some segments, and I go to see that roughly these segments correspond, coincidentally, a bit to the same edges of the little square coming down. At what height are we? How far have we descended? The computer can tell us this. Let's do the calculations.
Look, we know that the pyramid must be 137 meters. 137 meters correspond to a certain number of pixels. Beyond the fact that the topography with the tripe effect has been stretched, distorted, we count the pixels, there is no problem. And at that moment, we can have an indication. Let's look closely at the area at the bottom, where there is the little square, where there are two bright things, with above the entrance to a bright thing that looks like a cube, 4 things that descend, and in the other cube, 4 other things that descend. You see, it can also be seen on the right topography, where the cubic structures are seen better with these objects descending into one cube and the other cube. Between the two cubes, there's nothing, or rather, there's room for something else. You might say, yes, but you see it because you're used to seeing the topographies for years now, but I see nothing. All right, okay.
Phenomenon of pareidolia. Do computers, does artificial intelligence experience pareidolia? Does it invent things? Can it identify shapes that are fake?
Not technically, because the phenomenon of pareidolia is a psychoanalytic phenomenon. So, we ask the computer to analyze this area better, which seems to us to be roughly 2 cubes with a, if you like, a smaller cube in the middle, where in the first and second, especially the first, meaning the one on the left, in this, the 4 things descending because they are gray-brown. Basically, those colors that I cannot see, all the Mizoni colors I cannot see. The light greenish, light bluish, light pinkish, so I just make them up. And we asked the computer with artificial intelligence, can you tell me what the heck you see inside this thing here? And it tells you there are 2 cubes made like this. And he told you, look, one with a certain resolution, the other with another resolution, and he shows you exactly, if you see it, on the side toward the viewer, that is at the bottom, you see the darker stripes of the 4 things that go into these big cubes. Very well, Lemil. So, since the phenomenon of pareidolia, artificial intelligence has it, it must be said that evidently it is just like that. We did this here. But the opposite, with a computer trick, we removed the first cube, the one on the left, and tried to look only at what is on the right. Look. On the right, it is clearly visible that the corners of this large cube are highlighted in dark, and the stuff coming down from above, which looks like this strange spring, enters the cube. And it is clear because there are at least 2, if not 3 of these objects whose vibration is in our favor, and they enter directly into the big cube. So it's evident that we can now do a construction attempt. And the construction attempt is what you see. We've made several using different types of lights. For what reason? In the one on the left, you can see how the spring pathway has been recreated with a color that resembles a bit that of chromatography, topology, with these big cubes where here we are not shown because it doesn't concern us, but these objects enter these cubes are 80 meters each side, 80 by 80, and they are at a certain distance from above, which I will now tell you. In the middle, you see a 3D resolution. How we might say this stuff, if illuminated by whom? From a radar that somehow illuminates from a certain position and thus returns to you like a light the vibrations according to the line where the subject, the object, has somehow been influenced. And you see exactly the same things that you see in the topography. Not only that, in topography number 3, the white one, the light one, we made the tubes glass. Why? Because the tubes appear to us essentially as a glass. We can also see exactly the other part of the spiral. Imagine it as a spiral staircase going down.
And what do you notice in view number 4? That the shades of yellow are 3, not 2. What does this mean? It means that you do not see everything in front is nice and clear, everything behind is nice and dark, but behind there's a slightly darker zone, then a slightly lighter zone, then a slightly darker zone. What does this mean? Only one thing. There's a tube inside another tube. As seen in one of the topographies we observed earlier. Actually, there is a tube, an empty tube, not a column, it's an empty tube. Paraci, posetto. The problem that arises now is another. What is there between one box and another box?
This is the image enlarged as much as possible of this area. And you look at it at first glance and you understand nothing. However, I want to point out something. Do you see that in the middle there's a bright dot on the floor? Let's call it that. And there's a kind of small rectangle that's basically indicated because there is a bright dot in the middle. Yeah, do you see that there are cube-like structures that the eye can glimpse? I'll show them to you more clearly. Because this is the nail in the wall, obviously. And so you discover that there are the two big cubes. I marked the one on the right with a dotted line. The one on the left I did not mark with dotted lines. In the middle, there's the small cube that, as a floor, has a brighter point at the center. Now that you could have seen the nail in the wall, if I make it disappear, you have the chance to see exactly what was being highlighted. Now, at this point, though, we need to understand one fundamental thing. At what depth are we? Yes, 80 meters is the side of one of these really big rooms.
Let's have the computer do the calculations.
The computer knows because knowing that the height is 137 meters graphically, by counting the number of pixels, you can see exactly, this time we made the precise drawing, that the final point where there is this square shelf, where there are these two large cubes, each of which absorbs 4 columns going down, 4 big tubes going down. It's at 648 meters. You say, well, yeah, you see it like this, but we said, could the computer, please, can you resize the figures so we can see it as it should be? Here it is, yeah. If we flew over the radar and zoomed in, we would see this situation, that is the pyramid at the top and way down below. The pyramid is 137 meters high. There it goes down to 648 meters, more or less. The error we can make is related to the fact that the radar is not perfectly aligned vertically with the pyramid, so it is like this. An exact calculation is made with the Pythagorean theorem, essentially, and therefore it might change in part. But since the error we make on the 137 meters is the same type of error, because it has the same kind of angle, on the 648, you can be assured that it's 648 meters. 648 meters is the double of 324. 324 is a fundamental number because it is an idionic number. As I say, that is the length of the space axis, the length of the time axis. 324 divided by 2 is 162. I remind you that 1 and 61/8 is the golden ratio. Keep it in mind because this data may be useful to us in the future. Well, similar tubular structures existing in the world. If these tubular structures exist, who built the pyramids? Were they the first to build them? No. We also have one in Italy, the Well of St. Patrick. Now you look at it and say, damn, look at that. It's exactly like that one. Well, sure, it's shorter, it's smaller, it's more But look, it's made of something that's twisted around another thing, and inside there's a hole. How wonderful. This is obviously
National Gadawara, which is in India. In India, there are several of these structures that have been dated, scientifically speaking, poorly.
Why? Because
it is not possible to date stone with carbon-14, so it is necessary to date the artifacts that are attached to the stone. No? So to show the problem is an issue that we also have here in the city of Derinkuyu, which is one of several, but perhaps the most well-known, though not the largest, underground cities in Turkey. Look, there are lots of wells going down with the usual, what we would call the usual tadpoles. And you can have fun seeing that. No one knows when this city was built. They dated it to a certain historical period.
before Christ, but after.
Just because they found traces of objects that date back to that age. But this does not mean that this stuff is from that age. This means that someone found it empty, and ate inside and threw away the cans like we do, and we found the cans from 600 years before Christ. But this doesn't mean that since we found organic residues from that period, it was built during that period. You see, by the way, at the bottom left, you find a big, gigantic station, a huge cube, you might say now, with an obelisk inside. What a strange thing. What could this thing be, right?
This is one of the wells. 80 meters it goes down.
Just think about 2,000 years ago, at least, who would dig something like that with their bare hands, right? Okay, sure. Of course, it must have been the ancients passing by there. They didn't know what the hell to do. They said, what do we do? We've got nothing to do. Let's make a hole in the ground.
All right. No, just knowing is enough.
And so, at this point, we still ask artificial intelligence what it thinks of this stuff. And besides that, and we presented the tomography to artificial intelligence because we said, listen, this is a tomography. What do you see inside it? To me, artificial intelligence, incredible. This is a tomography done with the SAR technique, radar, the aperture. It already knew everything. Well, yes.
Point number 1, the presence of voids.
Artificial intelligence sees what we have observed and provided to it and says, if the darker blue areas in the radar scan indicate underground voids, they might suggest the presence of natural and artificial cavities, compatible with the idea of a system of vertical wells or hypothetical tunnels. That is, artificial intelligence is inventing everything. So, the vertical structures instead, and you can clearly see that the more linear bands that are extending vertically in the scan may correspond to structures similar to wells or columns, I would say, underground, such that, and it describes exactly what I told you, as well as the presence of anomalies in horizontal structures. And then he says, while I'm at it, the artificial intelligence, I'll make you a little drawing that matches what I see inside. And the little drawing was made by the artificial intelligence with the other dimensions and the horizontal plane, the vertical plane. It's not necessarily like that, but the artificial intelligence said so. Who made the artificial intelligence? It was made by those in charge. Of course, those in charge will say, no, the pyramids are empty inside. But they can't say that I, who created the artificial intelligence, that the artificial intelligence made a mistake. So with the study system, why do I question artificial intelligence? Not to get the contribution of artificial intelligence, but to make those in power understand that this time they cannot tell me that I am wrong because their creation said what I said. That's it. Does it work like this?
And now let's move on to the 3D construction of everything we have seen.
Look, let's take a little flyover above.
that thing you see that looks like a strange plane is the indication that there's, at a certain point, about 35 meters deep, a body of water that somehow doesn't allow us to see what's below. The wells are much farther, much more in low, but at the bottom there are these two boxes that represent the augmentation rooms, question mark. Look, and so you need to keep in mind, look how clearly you can see on the lower left the tuning forks that we will approach again, and we'll see that we also included that part. Dark, there you see that we saw from the tomographies. So we see exactly that there are 5 ZIDs that are connected to each other among all those paths that we saw in the tomographies, basically. Vertical, horizontal, X, Y, Z, whatever you want. And as you turn this operation, you see that you can put yourself in the exact conditions of the tomographies that we have developed, having essentially the same interferences that we had with the reality. Let's take a closer look. You see, there are these 5 objects, 5 Z's that are connected to each other by these clearer paths that are linked to those lighter edges that we have on the south, east, and west sides. There is no horizontal path on this side. North. The north side is the one with the entrance. The entrance is the path that will lead to Belzoni's chamber and has the lowest chamber, which, as Mei told you, cannot be entered because there is the pyramid scan doing its tricks. They can't even be seen here. That is, they are such a small and insignificant part of everything that technically, yes, we enlarge the image and see them. Here, from another angle, you see that using these angles, sometimes the Z's appear as 5, but sometimes they appear confused, one behind the other, and they exactly mimic the vertical paths of the spiral staircase, whatever it is, which we don't know what it is now. And they exactly mimic the same outlines that we have. Look, at the back, there's a large room on the right, and a larger room small on the left, which are behind the Z and are exactly in the same position we saw in the previous tomographies.
Obviously,
you see them from the entrance side. The entrance side, and everything we know about the pyramid of Khafre is below ground zero. That is below the line of the pyramid, the ground zero. And it emerges here from ground zero for a while, only the roof of the Belzoni chamber. Keep this fact in mind. The roof and the 2 shafts that we know evidently served as overflow. When the water enters, because it is needed for a certain thing we have already described in a previous conference, then the water must exit. So these 2 objects that serve to let the water out to prevent the pyramid from filling completely, they cannot be below the water level. They must be a few meters above the water level, and so they are above ground zero. And then there's the roof made like this. Now, having a 3-dimensional model is very useful because it allows you to understand, in this context, how you have exactly reconstructed the tomographies. If you look at this stuff, you see that when you look and do a tomography from this position of Z, you only see 3 of them. The one in front, the one in the middle, and the one in the back. With the 2 small rooms, the wide one and the narrower one, connected to each other, it is evident that at a certain point, keep in mind that these objects go even further down. And that there are 648 meters between the ground zero of the pyramid and the 2 white containers, let's say yellow, there. Here you see
Sometimes, like in this case, in the right Z, you can see a bit of the Z behind, just as it happens in the tomography we did from this position. So, high up, we managed to see that the spots colored in blue essentially represent the 8 objects seen from above that are going downwards. And why do we see them so little? We will know in a moment. But in 1968, muon spectroscopy had already conducted some analyses. The first time, it seems right on the pyramid of Khafre, muon spectroscopy was used. And where do they place the camera? For the muons. In Belzoni's chamber, it even rhymes. The camera is placed there. As rightly said, Filippo, you need to place the plate underneath to look at something that is above. We actually don't need to dig 2 kilometers underground to place a camera to see what is in the 2 kilometers above and below. We look at everything from above, and we don't care at all about making an incredible mess like these folks. They need to place a photographic plate and wait for the muons to impress it. In the center, they place the camera, which in an old, a photograph from that time, 1968, the one who invented this technique, that rightfully, as Armando Mei said, the Nobel Prize winner, so not just any idiot. And what is the result? They write it. We have no doubts. Do you think an Anglo-Saxon has doubts? We have no doubts. If there is a chamber or a series of things similar to the king's chamber,
What is inside the pyramid of
Khufu, and even in the pyramid of Khafre or any other things. Imagine if we don't see it. If there is a large gallery, we see it immediately. If the queen's chamber is underneath, we see it right away. Because we will photograph everything in the middle at a 35-degree angle. All right. They take the measurements. We haven't found a thing. It's written like that. Translated into English from Italian. It doesn't say. So don't worry, there's nothing. And on this declaration, Zakia was also chimes in saying,
certainly muon spectroscopy doesn't work.
And in saying this on a strategic level, he doesn't realize he is shooting himself in the foot. Why? Because he will then say, muon spectroscopy was met with resistance, but then he will say, muon spectroscopy, in the case of the pyramid of Cheops found something. But how? If it didn't work. If it didn't work, at least from being clever, there's nothing. That way, you're not shooting yourself in the foot. Instead, this is the scientific work that has been essentially published. 1968. So, we need to understand why this thing happened. There is one. The pyramid, we see it. In the clear panel, I go now overlay the cone of 35 degrees necessary to see something. And when I superimpose the 35-degree cone, I discover something incredible. The 35-degree cone does not hit any of the 4 Z's around it. So even if they are there, he cannot see it. Not only that, he was unlucky. Not only, but the Z inside is in the narrowest cone area, where there's the least probability of capturing muons. Area where usually you can't see a thing. Let's look at it better. Here you see, it completely missed them. You can't see anything. Muon spectroscopy doesn't mean it doesn't work. It's just that placing the camera under Belzoni's chamber was a mistake. You pay a fee.
Could it be for this reason that they have now placed the camera in the other room, the lower one, and don't let us see what's there? But how? If there was nothing, why do you need from 1968 to 2025 to try again from a different position, spending another $1,400 million?
$1,800,000 it costs. $1,400,000 the camera for taking morning photographs costs.
To this project have worked from 12 to 15 university institutes worldwide, with the contribution, it seems, of 30 or 32 people doing a photograph every 8 months, because muons are needed. If there are not muons, the film does not get exposed. No Sir Wolfgang Picard, man, no one, however, was impressed by the fact that we conducted a research and discovered 99.9% more of all the things there are without spending a damn penny staying at home. Pishiama pushira kaka.
The problem there is, you see, what all the newspapers brought out with great fanfare at the time of the famous Scan Pyramid is, we found 2 voids, one big and one little. The big void, which you see in the center, which they illustrate with this little drawing here, in other scientific articles, it is bent. That is, it has a bend. For what reason? Because the authors themselves say it in the scientific work. We don't really know if this big void is in a horizontal line or in a bent. It has an angle. Why don't we know? Because we found only 5 muons that passed through there and then came to our camera. 5 muons over a distance of 70 meters. I mean, couldn't it be 5 small big voids stuck to each other? We will never know. How tall is this big void? We will never know. Why can't it be known? Because this is the limitation of the technique. So, you understand well that in 1968, you say it was impossible for the 4 external Zides to be seen at all. And the intermediate Z, when 3 muons pass through there and by chance they collide, they interact with the empty parts of the Zid, which are numerous because they are essentially the 70, the Z is 70% empty, if you think about it in terms of volume. So it's impossible with this technique, but they know there's something inside there. It also likely bothers them that we have found something, so they are trying to catch up by also trying to say, and rightly, we care for them a lot, because then they will say they have discovered some little rooms, 2 or 3 of the ones we have already discovered today. And we are pleased about that. So here we need to talk about the structural data of the pyramid. Why can't we actually see the structure that we know? It's hardly visible. Because the pyramid is made that way. If it's not done like that, a billion tons of whatever it is sinks into the sand. If there isn't a slab that supports it, this slab essentially sinks into the sand. And today, we would have the structure of the Pyramid of Khafre 50 meters underground, because you cannot build anything on the slab. So, this slab, essentially, we can see it in a first approximation, either from the right or from the left. If we look at it from the left, let's pretend it's a beam. This beam is supported by 4 poles, which are the 4 pipes we see in front. And this, he says, all right, at the center of the pyramid, I have the right support so things don't collapse. But if we look at the pyramid from over there, that is from the right, we notice that the beam showing the cross-section of the pyramid is essentially a double cantilever beam. That is, there's 2 things in the middle, and here 2 small wings that hang. And so what you see, especially at the bottom on the left, is the flexion graph. Like this, like this, like this, the flexion graph.
the more weight you put in the middle and the more you shorten the distance between the two supports, the higher the graph goes, drops down, rises back up, and drops again. You know, you see that they seem like the tensors, the cables of the Brooklyn Bridge. Do you understand why the Brooklyn Bridge is made that way? Because it follows the bending moment diagram of the cables. Now, granite, the rock, let's say, in general, granite in particular, withstands pressure excellently, practically doesn't undergo deformation, even under infinite pressure, but when sheared, that is, to a thin slice of granite that breaks, it won't hold. If you hit granite hard with a hammer, it will break, but if you try to press it, rest assured, you will never manage. So we had to do a bit more precise calculation. We thought there was a plate that supported the pyramid. And maybe these 8 objects are used to support the entire plate that in turn supports the pyramid, because otherwise everything falls to the ground. So in this graph, without me showing you the numbers, we calculated the size of the plate to see how high it needs to be. Why am I telling you this? Why this thing? The plate is there. It can be seen. And there are these gigantic stones that not only occupy the opening of the pyramid, as in this rough calculation, if you like, but they extend even further, increasing the support surface. So I asked artificial intelligence, Tapiches, then we checked the calculations, but artificial intelligence says minimum thickness of the plate is 4.5 meters, otherwise everything collapses, meaning it sinks by at least 10 meters.
Considerations. Hey, you should put some poles in.
Oh, and artificial intelligence says it. I didn't say it. Zahi Hawass didn't say it. And so we redid the calculation. And redoing the calculation, tada, you gain by putting in pillars.
As we designed them, with the dimensions we more or less see from the tomographies, 31%.
That is, it doesn't sink more than 10 meters. It sinks 6 meters, essentially, the settlement. But I calculated the plate that had the same dimensions as the pyramid, not a plate that expands 15 or 20 meters outside, because then surely even more the pyramid doesn't fall.
Do you want to see that these objects have at least one function?
At least one function, like supporting. Because if not, and then, damn it, we asked ourselves, what about the other pyramids? And that's when we went to take a look at the old tomographies, the ones on the Pyramid of Cheops.
And then we realized that we hadn't noticed. But damn it, there are also objects descending there in the Pyramid of Chephren, in the Pyramid of Miserinus.
And look, this is a section. In this section, you see how we place the known stuff at the level of the plate. What you see is that we cannot see, except in a way. There is a scientific term that is humorously referred to as by accident, the vibrations of this entire dark path, because it falls within this giant plate, which will nevertheless absorb all the vibrations. The signal-to-noise ratio is unfavorable for seeing. But the roof extends. The roof of Belzoni's chamber extends out of the slab. It's higher. And therefore, essentially, all the vibrations inside the slab are not visible, but the vibrations outside are. But what is the point of building this something? It makes sense, because if we, who have always maintained that the pyramid is a tool, a bell that serves to gather vibrational information, force and bring them to the floor below, the vibrations pass through the roof of Belzoni's pyramid, which must be outside this kind of hard base that would absorb all the vibrations and wouldn't do what we have already decided it does in the past, let's call it episodes. We had to take a look at this point, first look at the plane, the Egyptian plane. There is stuff down here that we haven't noticed, we haven't seen. For crying out loud, how do we do it? So what needs to be done? We need to widen the spectrum. So make the tomography larger, go further down, more to the right, more to the left.
This requires more machine time because it's the Fourier transform.
Each brushstroke that we apply to this photograph, it is spread over a larger number of square pixels, so it takes a lot of time. So let's take the pyramid and make a cut in the middle. I remind you where the north is. Look, the north is at the bottom, so that's where you enter. This is a satellite central image, not an optical image, so you see it slightly distorted. Well, on the right and on the left, you see how it appears to us. The cut of the film, right? We are cutting the cake like this. We cut the pyramid in the middle of Khafre in two. For anyone observing the scene from the right, they will see the pyramid of Khafre as that object that resonates best because the cut was made right there in the middle. The pyramid of Khnum Khufu appears behind us, while the small pyramid appears farther away, as seen essentially by an optical one who sees. What would you see? You would see the photograph as it appears on the left, meaning almost one behind the other, the three pyramids. But look, pay attention. The pyramid we are viewing with the central topographic section is the pyramid of Khafre. But notice that while we are looking at the pyramid of Khafre, you have to realize that behind it is a bit of Menkaure on the left, and in front on the right, there is the nuisance of the pyramid of Khnum Khufu, which will somehow do something that what we see here might be due to the pyramid of Khnum Khufu. This is the valley. In the middle, you have the little triangle. You recognize it. The pyramid of Khafre, you see the black cone that descends, which corresponds to the two edges, the one in front of you and the one on the other side behind, which do not vibrate. You see a sort of object in the center here that descends slightly bent and is the sum of the first tadpoles of all 8 tubes that descend, since it's attached nearby. On the plate, you can clearly see that it vibrates a lot, because you can clearly see the things that are attached to other things that vibrate a lot. I would like to point out that a similar structure can be found on the right. Do you see that there is a brighter path at a certain point on the right, and at the top, this tadpole that descends, the first tadpole that descends and occupies a certain number of tubes. At the top, there is the edge of the pyramid of Khnum Khufu. So, under the pyramid of Khnum Khufu, there are also things descending. First observation. Second observation. Let's look in the center where the arrow is. Actually, I should tell you to look at the bottom left. At the bottom left, there is a luminous structure. This luminous structure is basically right under the pyramid of Menkaure. Well, if it's a luminous thing, it's something that vibrates, it's something different. Well, I point this out because later we will also have to bother Menkaure. The central arrow shows you the usual glowing quadrilateral square that you see due to this fake 3D effect caused by the fact that the alignment between the pi folding of the radar is not the same as the folding of the tomographic image, which should technically be vertical, thus giving us a distorted verticality response. This helps us because it gives the idea of a three-dimensionality that isn't there. There, in the middle, are the famous big cubes. So, at the level of the arrow, it is 648 meters from ground zero.
But there are 600 more below of stuff underneath. I will point it out to you.
Let's see the big cubes up close. You can see basically the edges of the cubes, how they are made, because they have been highlighted, and these edges evidently must have a strong vibration, because from a lighting perspective, the edge in this context is always very prominent. And there are two cubes, so and they are separated. In between the cubes, there must be that smaller box I was showing you well earlier. Do you know what the dark stripe descending on the right is? It's the two edges of the pyramid of Kunum Khufu, which we see in front on the right, but is actually behind.
To the camera, because the camera took an image that goes forward and backward and compressed all the information onto a single plane.
So this is to say, let's get even closer. You can see even better the cubic structures, which moreover, the computer said are large cubes.
And there, obviously, you can see other things, which we do not know what it is, because the only way to understand it is to go there.
And what is this stuff here? This reflection here?
This reflection here.
At the beginning, as usual, it's a reflection. Yeah, no, it's not a reflection. Let's look at it closely.
When we look closely, we compact it with the tripe effect that we can make. So we make the pyramid appear as a real pyramid, well made in the center. You see how the darker vibration in the center becomes even more effective. We have launched, how do you say, increased all the black and all the white a lot more. We have spaced them out somehow. It's more visible. And the thing descending, you see that it's actually a kind of black square descending with two paths that are
almost parallel to each other as they descend. But we have seen these somewhere before. But what is this stuff?
And look. Let's take the two models of the two pyramids as they are, and we discover that yes, under the pyramid of Kunum Khufu, which is on the right, and in the tomography, corresponds to something behind the observer. There are these two little jerks going downwards that you see them from above and you see them bent like this. They are, in this model, the distances have been respected. That is a scale model, this one, also with the distances. So what the heck is this stuff here? Something that's under the pyramid of Kunum Khufu. We find it again in this tomography. See how it is? The pyramid of Kunum Khufu is the one in front, but which is behind the observer, because we've cut the cake in half of Khafre behind. Underneath, you can clearly see that in the same position of the work we published on motosensing, which a female Egyptologist said, but they are just light spots. You can't see anything. Maybe it would be better if she looked at it again. Perhaps she's colorblind, who knows? Let's look at the situation from above. This is the situation from above. You see, there are the two pyramids that we have placed with the correct dimensions. There's the Sphinx on the right. Let's see if we can somehow do a three-dimensional tomography. And if we do a 3D tomography at a certain point, we can go under the pyramid, under the... and see. Oh, but what's there? Underneath, look at what a little den is there. What a wonder. And at this point, it's clear that starting from this situation, we could somehow build a three-dimensional scenario, which we will do soon, on the whole Giza Plateau. Because you can no longer say, I studied the Pyramid of Khafre, or I studied the Sphinx. There, you must study everything as a whole.
as Mei rightly says, in a single context. Let's return to this image that has been provided to us. This is the space chapel, which has the largest resolution in the world, so it couldn't get better than this. What is all that stuff that is essentially, from our point of view, under the pyramid and partly of Khafre and under the pyramid of Khufu? What is all that stuff? Let's take a better look. We have moved slightly. You see, the pyramid of Khafre is in the middle, but while before the highest point of the pyramid and the two sides were one on the right and the other on the left, now they are in this other way. This means that we have shifted the tomography in this way here. And you watch and discover, take a general look so you realize that there are things that go down, and then we'll understand why there is so much confusion.
But down below toward the bottom, that are 1,200 meters from the baseline.
There are square, quadriform structures, like Roman cities, essentially, which indicate structures that definitely cannot have been made randomly. You can clearly see everything we have seen and more. There are things, and there are many things. This is a amplification, and you see these structures. Now you can see what you see, but there are vertical situations, horizontal situations, and practically these situations are geometrically linked to X, Y, Z at all angles of 90 degrees. Now, you can't tell me that these structures are invented, that they don't exist, because this is a tomography. That is, it's a sound photograph, not an interpretation by the first person who walks by. This tomography here essentially shows you the cut we made, and from here you can see something fundamental. Look how much stuff is coming down. So, we will also have to review the tomographies we have already done previously to verify, and something we are partly doing, even under the pyramid of Khufu. Look. Compacting another tomography, you see that we always place Khafre at the center because it was our starting point, but below, we are interested below, you see, the central part is the columns descending, this stuff here that goes down. We have put them together, and it basically becomes a single object descending. However, if you notice, and you can see it in the latest tomography, there are essentially square structures. Let me show you better. And you see, here are the shafts that go down. Then finally, the single block dematerializes, and you can also see all the fingers of this structure. But on the side, if you pay attention, there are rectangular structures. I will show them to you better. Here it is. Now that you've seen them, I'll outline them for you so you can see them with your own eyes. It's a bit like the game of the nail in the wall. These are very large structures, especially height, length, width, etc., etc. What you are seeing is that this structure has as its center this giant square, the column of columns that descends from the pyramid of Khufu. While the brighter one, because it is exactly where we did the tomography, is the one at the center of the tomography, which is in front of us and has nothing to do with the giant square that I am showing you now. This is how tomographies are interpreted once you get the hang of it. Obviously, everything comes proven by horizontal tomography, because now we are scanning the entire plateau. But not satisfied with this, we changed the angle. Let's position it at 90 degrees. 90 degrees, yes, in the true sense of the word. We are in a stroke of luck. We are in a stroke of luck, says my uncle Skevola. You see the tomographic line. It goes from the pyramid of Khafre all the way to the left to the Sphinx. Well, at the top, you see the tomography. God damn it! Do you see all that stuff coming down? How much stuff is coming down? If you rightly overlay the tomography
on those vertical lines. Those vertical lines bother an identical number of wells that are in the Giza Plain and that no one has ever scientifically bothered with. This means that those wells go down to a depth of 1,200 meters, more or less the same, in some points more, in some points less. And in this tomography, we got carried away by he says, let's take one of these wells, let's go see. And we took one of the brighter ones, meaning it would give us more information on the top left. Yeah, I'll show it to you better. The Well of Osiris. So, the Well of Osiris is that well which somehow is believed to have been the tomb of Osiris. They have told us all sorts of things about it. And I will show you something fundamental. In the Osiris shaft, there are 2 or 3 levels, essentially, that reach up to 35 meters. After that, it's unclear what happens because there's a watercourse surrounding a granite structure where inside it seems there might be a sarcophagus or one of many objects used for putting something inside. If it was a sarcophagus, as the Greeks say, meaning a body eater, or it was a neb-ankh, as the ancient Egyptians called it, neb-ankh means a place where life takes refuge, which does not mean eater of bodies. So already the wireless telegraph, the wireless phone, in the first translation, they had already messed up, the Greeks. So imagine today the Egyptologists.
Well,
we don't know where this water comes from. We don't know where it goes. It's a completely different water from chemical analysis compared to the Nile water, so it follows a completely different path. One of our future goals will be to find the water paths there underneath because they play some strange tricks. Someone has already studied them from a scientific and technical point of view, but the geological works that I studied and also submitted to the analysis of some geologists I know, I was told that they were poorly written, so all the data needs to be reviewed because there are truly interesting things that we will show next time. Look, a fundamental feature is that on the second level, the first level is the entrance. On the second level, there is a series of rooms that we will see better where there is a sarcophagus. This sarcophagus has 2 fundamental characteristics. Of these 6 small rooms that are there, one of these sarcophagi, that there's essentially only one. In reality, there were 2, but I believe one was removed. It's made of granite that is not found in Africa. I don't know how they put it inside because it doesn't fit through the entrance. It weighs the usual 70 tons, 80, I don't know. It is slightly radioactive, among other things, but probably comes from some mine in Turkey. Now, it should be brought there, and someone should ask us how they brought it. We don't know. So, you see, I've put the map of the path, and next to it, the tomography of the path. As you can see, in the tomography, there's a first vertical path, then there's a first step, a second, and a third. The first dark spots you see in the well are the third level. That is, there we are at 35 meters.
And below?
Below there are things. And further below, there's also a black thing, which is a little room. What do you want it to be? Maybe not. It's a thing of tungsten that will vibrate differently so it appears black. To me, it seems that it might be more likely to be a small room, or rather a large room. This stuff goes down another 100, 200 meters below you at least, just based on the first calculations of the pixels. This stuff
has never been seen by anyone.
And there is why.
Because you can see it.
Here, this is the structure, and the synthetic aperture radar has captured it exactly. And we identify it exactly because we know how the structure is made. And every time we know how a structure is made and we look at the tomography, we can recognize the colored spots because they correspond to the structure we have.
In the pyramid of Kinumkufu, we were advantaged because we had 2 or 3 structures that we knew, and we could recognize them. In the pyramid of Khafre, there was nothing that we knew inside the pyramid. And so we had to work much more to understand what we were facing. So there's a first vertical section where all these little rooms are. In one of these, there's the only remaining sarcophagus. In the lowest part, which it's this, there's the sarcophagus. The large sarcophagus, I don't know what it is, but once again, we have water entering from one side, water exiting from the other, and this object in the water experiencing vibrations. I don't know if it reminds you of anything we discussed in previous conferences here. So at this point, however, we need to say what our eyes have been. Mine, just one, is half blind, but actually one of our eyes has been umbra space. That is this kind of giant umbrella through which its opening allowed us to have a synthetic opening substantially favorable so that we could understand all these things. And the other, the one that allowed us to go even deeper, is umbra space, capella space, which basically, as you can see, is a kind of large, open, rigid sheet that allows us to take out all the data that we essentially extracted, the moral of the story.
One must draw conclusions, and the conclusions are quite simple.
For us, the pyramid is like a safe full of information, and this safe full of information has been closed by somewhat dubious characters who not only prevent us from looking where we should have been looking for a long time, not only us, but also other research groups, but essentially they continuously modify these monuments to prevent us from seeing them in their pure state as they were. At the beginning, before the modifications were made, it was possible to understand what these pyramids were for. So this synthetic aperture radar, essentially, the 2 radars we found managed to open this safe. Inside this safe, of course, is what I call the truth, the reality of the facts, the irrefutable reality of the facts. So the synthetic aperture radar becomes once again SAR without any hesitation. Why? Because this will be the drive that will push us forward relentlessly to bring out everything we can from this objective reality, presenting it to those who think that Egyptology ends with H. Thank you.